5 square and this 10, it will be gone. We will get 36 into 25 into 10 raised to power minus 4 by 2.
So we are going to use the equation of work done minus nRT log of V2 by V1 for isothermal processes.
Similarly, we have to find the B. In fact, we need A square. So A square here would be the square of this thing, which is actually minus 3.
Hello, dear students. My name is Vikas Agarwal, and I'm here to present the physics solution of entrance cum scholarship test of Eklavya. So let's begin with the first question. So the first question says that a stone which is thrown vertically upward with an initial speed u from the top of a tower reaches the ground with the speed u, the height of the tower. Now, the easiest way to do this question is to make use of the work energy theorem. Let's say this is a tower of height h, and let's say a stone was projected upward from this point with a speed u, and this stone went up and then it came down, and when it came down, it had a speed of 5u. All right. So in this entire course of motion, the only force acting on the particle or the stone would be the force of gravity. And how do we write the work done by gravity? That would be written as weight of the block or the weight of the stone into the change in height, rather the decrease in height. The decrease in height is same as h, so this is the work done by gravity. This should be equal to the change in kinetic energy, which will be equal to half into m into 5u square minus half into m into u square. So we need to solve this equation. In this equation, we can see that m is going to get cancelled. Okay, so m and m, this will get cancelled. And therefore, when we continue solving, we will get h as this will become 25u square minus u square by 2. So 24 u square by 2. And then g will come from the other side. So this will become 12u square by g. And we do have an option like this, option D. So that would be the correct answer to question number 1, as we can see here. Now we will go to question number 2. This question says the speed at the maximum height of a projectile is half of its speed at half of maximum height. Now, this entire statement looks a bit complicated. We'll try to break it down into several parts and then we try to understand. So the question talks about the speed at the maximum height. So we know that if we project a particle with a speed u and at an angle of projection theta, and then it travels like this, and at the highest point, the speed of the particle becomes u cos theta. So this part, the speed at the maximum height of the projectile. So we are talking. So this is the one entity. This is one entity in the statement. So this entity is u cos theta. Now this speed is half of something. All right. And now what is that something? That it is half of something. That something starts from here. It is speed at half the maximum height. So we know that the maximum height for a projectile is u square sine square theta by 2g. So half of that, all right. So half of that height would probably be somewhere here, and this speed is v. If this speed is v, so according to the statement of the question, it is given as v by 2. All right. Now we need to find out the right expression for v. So we are going to do that. So if we are trying to find the right expression for v, let's understand this, that even here the horizontal component of the velocity will still be u cos theta, and let the vertical component of the velocity be vy. All right, so in the y direction, I can write vy square is equals to uy square plus 2ay into sy. And starting its journey from here till here. Here, the initial component in the y direction would be u sine theta. So we would be writing vy square as u sine theta square of this plus 2 times the acceleration in y direction is minus g into displacement. Displacement is half of this height. Okay, so this will become u square sine square theta by 4g. So from here we are going to get Vy. Once we have the value of Vy, we can then find out the value of V. Okay, the value of V will be given by Vy square plus u cos theta square and then root of it. Okay, so let me first calculate the value of V square from here. So it will become u square sine square theta minus u square sine square theta by 2g. This calculation will become 2g. So ultimately it becomes u square sine square theta by 2g. Now this is the value of Vy. Actually 2g will not be there. It will only be 2. This 2g and 4g. So only 2 will be there, guys. So the just g will not be there. U square sine square theta by 2. Okay, now the value of V. Value of V would be root of Vy square. Okay, so that is u square sine square theta by 2 plus u square cos square theta. So this is the value of V. All right, so we can revert back to this equation and we can continue our solving. Let me do the square of this entire equation. So when we do the square of this entire equation, what we will get here is u square cos square theta is equals to 1 by 4 times of V square, and V square will be equal to, from here, see, V square will be equal to the square of this. So it will become u square sine square theta by 2 plus u square cos square theta. And you can see here that u square is present in all the terms, so we can cancel out. So u square, u square, u square, all of this gets cancelled out. And we can take the 4 on the other side. So it will become 4 cos square theta is equals to, let's say, sine square theta by 2 plus cos square theta. So from here, this cos square theta can be removed and this 4 can be made into 3. So from here, we are getting the value of tan square theta as 6, or in other words, we are getting the value of tan theta as root 6. Once you have the value of tan theta, you can readily find out the value of sin theta and cos theta. For example, if I mark this as root 6 and this as 1, this becomes root 7. So now we know the value of sin theta would be root 6 by root 7, and the value of cos theta would be 1 by root 7. And now we can find out the range. The question asks the range of the horizontal plane. So we need to find out this distance. Okay, so how do we write the range? The range is written as u square into 2 into sine theta into cos theta by g. We just need to substitute the numbers now. So u square into 2 by g into sine theta, that will become root 6 by root 7, and into cos theta, that is 1 upon root 7. So it becomes 2 root 6 in the numerator, and then u square will also be there, and then 7g will be there. So let's see whether we have an option like this or not. 2 root 6 u square by 7g. So option C will be the right one here. So we see that option C is the right one. All right. So this question was a bit lengthy, as when you consider that this question is meant to be a JEE main kind of question. So yeah, it was a bit of lengthy, but then you can expect that. This is Eklavya scholarship test, so you can definitely expect a bit of higher level as compared to the JEE main. Okay. Now this question says sound of intensity I is greater by this much decimals from another sound of intensity 10 nanowatt per centimeter. Now the absolute value of the intensity, we are seeking the value of this in watt per meter square. Now, guys, pay attention to this. The intensity given here is in 10 nano. It's nanowatt per centimeter square, and here we are seeking it in watt per meter square. Okay. So first of all, how do we define the loudness? Okay, or the decibel scale? It is 10 times and then log of the intensity divided by this. So the question says that the intensity is this. So if I write the loudness of this intensity, I would be writing 10 log I by I naught. Okay, where I naught is the reference intensity, that is a minimum intensity to which human ear is sensitive. The value of which is actually 10 raised to power minus 12 watt per meter square. So the difference of these two, so 10 log, and then here we have been given an intensity 10 nanowatts. So let me write it as I1, okay, I1 by I naught, and this difference is given to us as 4.7712, quite peculiar number, I would say. So this will then become log of I by I1 is equals to 0.47712. See, I've done some calculation. I divided the entire equation by 10. Okay, so the right hand side became 0.47712, and then I adjusted the log to this. Now, if you notice carefully, this is nothing but log 3. Now, am I expecting you guys to be aware of the value of log 3? Probably not. But given that you do a lot of calculations, you can estimate that if we were to, find out, or we were to make a guess that what this number could be, you should be able to recall that it should be log 3. So from here, we learned that I by I naught will be equal to 3, which means the intensity that we are looking for would be 3 times of I1. So it will become 3 into 10 into 10 raised to power minus 9 watt divided by centimeter square. Centimeter square will be converted to meter square. So that will become 10 raised to power minus 4 meter square. And so this gets cancelled. This here becomes 10 raised to power minus 5. And then 10, so 10 raised to power minus 4. So 10 raised to power 3 into 10 raised to power minus 4 is what we are going to get. Like when I adjust all the powers of 10, I end up getting into 10 raised to power minus 4. And I can see an option C in which 3 into 10 raised to power minus 4 is given. So option C would be the right one. Okay, so that was our third question. Now we move to question number 4. Okay, now this is an extremely good question, guys. It says that two particles P and Q describe SHM of same amplitude, same frequency, along the same straight line from the same position. Now, guys, understand this that when we are trying to represent the SHM in the form of a circular motion, okay, when we are trying to do that, in this comparison, what happens? Let me just summarize it for you. In this comparison, the radius becomes the amplitude. Okay, the radius becomes the amplitude. The angular position, all right, the angular position becomes the omega t, all right, or the angular velocity of the circular motion, that becomes the angular frequency of SHM. Okay, and then we can assume that the y coordinate here, okay, that represents the position in the SHM. Okay, the mean position in the center of the circle, that becomes the mean position. Okay, that becomes the mean position, and the frequency at which the circles are completed, the number of circles completed in 1 second, that becomes the frequency of the oscillation. So all this comparison happens. Okay, now we are two particles are executing SHM of same amplitude, same frequency, along same straight line, along the. So what we can do, we can assume that the circle that we are going to use to represent their motion can be the same because everything is same. And if one of the particles is going like this with omega, the other particle is going like this with omega, with certain amount of phase difference between them. Okay, with certain amount of phase difference between them. And the most important point to notice here in this understanding is that this length will remain constant. Imagine this, as this rod is as this radius is rotating with some angular velocity, even this is rotating with some angular velocity. So it's like a triangular frame made up of rigid rods, which is actually rotating. So this length never changes. And what does this length indicate? Let's try to understand that. If one of the particle is here, then its position on the y-axis is this. If the other particle is there, its position on the y-axis is this. So the distance between the particle is this. In other words, this chord of the circle, the projection of this chord on the y-axis indicates the distance between the circle. And when will the projection attain a maximum value? All right, think of this. When will the projection attain the maximum value? So the projection will attain a maximum value when the chord becomes parallel to the y-axis. So when the situation becomes like this. Okay, so in this case, the projection on the y-axis will have a maximum value, and this is true for all such questions. Whenever such question would be asked, you would be given the same omega, because if same frequency is not given, then the angle will keep on changing, which means that the particles will cross each other. So if the particles are crossing each other, then they are separating, then they are again crossing each other. It means that there is no point of talking about the um, uh, maximum distance between them, because at some point in time that distance will also become equal to the amplitude or to twice of the amplitude. Here they are moving with maintaining a constant distance between them. So and that distance is the length of this chord. So if this distance is 1.2a, if this is 1.2a, and a is the radius, then this means that this is 0.6a, which means that this angle would be 37 degree. So the phase difference will then become 74 degree. All right, now if you look at the options are not given in degrees, it is given in radians, and we have to look for the closest value. So 74 degree, the closest one, if you ask me, what is this? How much is this? Like, see, this is 90 degree, this is 90 degree, this is 30 degree, this is 60 degree, and this is 5 by 50. So that is approximately 72 degrees. So the closest one is option A. So option A would be the right one here. All right. So that was question number 4 for you. Now we go to question number 5. Now it says a liquid is kept in a cylindrical vessel which is rotated about its axis. The liquid rises at its side, as the sides. The radius of the vessel is given. To do this question, you need to be aware of the theory here. For example, if we take a cylindrical container, and then we fill, maybe partially, we fill this container to some height with a liquid. Okay, so this is how the liquid will be. But then if I start rotating the liquid, if I start rotating the liquid with some omega, then the kind of figure we will witness in that case, the kind of figure that we will witness in that case would be somewhat like this. Okay, it would be somewhat like this. Like, we'll get a profile here. Okay, and it is possible and easy to prove that this profile is actually parabolic. This profile is parabolic, and not only that, if I consider this point as the origin and I make this as the x-axis and this as the y-axis, then we can also write the equation of this curve. Okay, and this equation turns out to be omega square r square, where r is the radius. Or no, I should not write r square. Actually, I'm writing the equation. So I need to use x square. So omega square x square by 2g. So this is the equation. Now, in this question, what has been asked? The question is telling us that the liquid rises in the sides, the radius of the vessel. So this distance is given to us, and the speed of the rotation omega is given to us. Okay, 3 revolution per second. The difference in the height of the liquid at the center. So from here and the side. So this is the height we've been asked, or you can say that the y coordinate of this point. The x coordinate of this point would be equal to the radius, and whatever is the y coordinate, when we find it out, then that will become the answer, because this height would be same as it is what is being asked. So it's very simple actually. The answer that we are looking for is omega square r square by 2g. You just need to substitute the numbers. Now omega is given in terms of revolution per second, and one revolution means 2 pi radian. So it would become 6 pi radians per second. Square of that into r square. Radius is given to me 0.05, so I will write it as 25 into 10 raised to the power minus 4. I've already done the square of that, divided by 2g, so this will become 2 into 10. Okay, now when you do the calculation, notice it is given here that pi square can be considered as 10. So here, from here we are going to get a pi square, but it will get cancelled from what we have here. So pi square and this 10, it will be gone. We will get 36 into 25 into 10 raised to power minus 4 by 2. Okay, so this will become what? This will become 18 times. So 18 into 25. 18 into 25 will become 1800 by 4. That's 450. Okay, so that will become 450 into 10 raised to power minus 4 meter. So if we are trying to express in centimeters, it would be 450 into 10 raised to power minus 2 centimeter, or 4.5 centimeter, that is 9 by 2. So option C would be the right answer. Okay, so that was question number 5 for you. Now we will go to question number 6. Question number 6 says that the pressure and the volume of an ideal gas are both decreased in the process. Now we are decreasing the pressure, we are decreasing the volume. Because we are decreasing the volume, then we are sure that the work done by the gas will be negative. So statement 1 is definitely right, and this is definitely wrong. Now also keep in mind that for a fixed amount of gas, the product of pressure volume, this product is an indicator of the temperature of the gas. If P has decreased, V has decreased, then it is for sure that the temperature would also have decreased. So work done by the gas is negative. That is correct. The temperature of the gas must decrease. That is also correct. Heat supplied to the gas is equal to the change in internal energy. Now that's not right, because we write Q is equals to delta U plus W. If heat supplied to the gas is equal to the change in internal energy, then it means that the work done by the gas is zero, which is not. All right, work done by the gas would be zero if the if it's a constant volume process, if it's an isochoric process, but it is not. So therefore, this statement also becomes wrong. So out of the four statements, only first and third are correct. So option C would be the right answer. Okay, so option C is the right answer. Now we go to question number 7. It says, in a thermodynamic process, pressure of a fixed mass of a gas is changed in such a manner that the gas releases. Okay, now let's understand this. We write the first law as Q equal to delta U plus W. Here, Q is the amount of heat supplied to the gas. Because in this process, gas is releasing the heat, so Q will become negative. Okay, and then work done on the gas. Now, here W represents work done by the gas. 60 joule is work done on the gas. So I will write it minus 16 here. So from here we get the value of delta U as minus 32, and delta U is U final minus U initial. So U final would be UI minus 32, and UI is given to be 80 joule. So 80 minus 32 would become 48 joule. So 48 joule would be the right answer to this question. So that was question number 7 for you. Now we go to question number 8. It says the boiler is made up of a copper plate. So you can imagine a boiler, all right, which is made up of, two different layers of metal, or two layers of different metal would be the right way to put it. Okay, somewhat like this. Okay, and then this contains boiling water. Okay, so this contains boiling water, which will have a temperature of, let's say, 100 degrees Celsius, and then it is exposed to gases, which basically means flames. Okay, so here we have flames, and the temperature of the flame is 700 degrees Celsius. It is given the question, and this area, all right, this area. Okay, this area is 500 into centimeter square, 500 centimeter square. So the amount of the steam that could be generated per. So guys, what is happening here? Because of the temperature difference across the base, because of this temperature difference, heat is flowing like this. Heat is flowing like this. So we will find out the heat current. So heat current multiplied by 1 hour. 1 hour is 60. So this much amount of heat would be supplied to water. So how much water will boil? Okay. So how much water will boil? So we will write it as M into LF. Now we'll take care of the units and we'll do the calculation. So let me first try to find out the resistance. So there are two layers here which are connected in series. So the thermal resistance, it is written as L upon Ka. So it will become L1 upon K1A plus L2 upon K2A. So that will become your resistance. Now let's start substituting the value. So L1 would be the thickness of the copper plate, that is 2.4 mm. I also notice one thing, that the K is given in calorie per centimeter per second per degree Celsius. So I will use the thickness also in centimeter. Therefore, I'm writing 0.24 here. All right. I have converted this into centimeters. So L upon K1. How much is K1? So for this one is copper. So I'm going to use the value of K, which is given for copper. So it is going to be 0.9. Okay. And if you want to take care of the units, let's think about them also. This is in centimeter. K is given in calorie per centimeter. So the centimeter will go in the numerator now, because it is calorie per centimeter. So I will bring it here. So, and then second, and then degree Celsius. So this is, and then we will divide by area. Area is 500 centimeter square. So you notice that this centimeter square gets cancelled with this. All right, and now that I know that what are the units that I'm going to get, I'm not going to worry about the units when I write the second term. Okay, let me probably make it a bit higher. Okay, so for second term, the value of thickness is zero point 0.2 mm. I'll convert it into centimeters, so it will become 0.02. Okay, it will become 0.02. Then I will divide it with K10. K10 is 0.15. Okay, so this is 0.15, and then area, which is 500. So let's do this sum. Okay, we will be required to do a bit of calculation. Let's do it here. Okay, so RTH will be equal to RTH will be equal to what is this? So 0.24, 0.90 you can write. So 24 by 90, and then there would be 500. Okay, plus this would become 2 upon 15 into 500. Okay, so you can cancel this out. This will become 6 times of 4 and 6 times of 15. And then I can pull out 15 into 500 as the common quantity. So this will become 4 plus 2, so into 6. And then I can further write 3 times of 2 and 3 times of 5. So this will become 1 upon 1250. Okay, 1 upon 1250. And what would be the unit here? The unit can be noted down from here. It would be um, this R would be second degree Celsius per calorie. I will write it here. Second degree Celsius per calorie. Okay, so we have found out the value of RTH. Now we can write the heat current. Heat current will be given by temperature difference. How much is the temperature difference across this layer? One side 100, other side 700. So the temperature difference is 600. 600 divided by the thermal resistance. Now keep in mind, this is 600 degrees Celsius. So we divide it with 1 upon 1250. And the unit here is second per degree Celsius. And the calorie goes in the numerator. So this degree Celsius gets cancelled, and we get calorie per second. Okay, so calorie per second. So we've got the heat current. Heat current in calorie per second. So we multiply it with the number of seconds that we have in 1 hour, and this should be equal to M into LF. How much is LF? LF is 540 calorie per gram. Okay, so I will write here 540 calorie per gram, and you see that I was a bit concerned about the unit, but I think they have taken care of themselves. For example, this calorie gets cancelled with this calorie. Okay, the second gets cancelled with the second. So I'm going to get the mass in grams. From this calculation, whatever I'm going to get, I'm going to get it in grams. We can also already see the answer here, but let's finish the calculation. So this will become 600 into 60 into 60 divided by 600 into 60 into 60 into 1250. Here is 1250 divided by 520, and this would be in gram. If you want to convert it in kg, because all the options are given in kg, then I will divide it with 1000, and now I'm going to get the answer in kg. Let's finish the calculation to see what we are getting. Okay, now to finish the calculation, 6 this will become 9 times, then 3 times, this will become 20. Then again, this gets cancelled, this becomes 200. So we are getting 200 into 20 into 1250. Okay, so we can also get rid of the 3 zeros here. Let me do it in this color. So 2 zeros from here, 1 zero from here gets cancelled with this. So now 4 into 1250, which is clearly 5,000. Okay, 5,000 kg. So we are getting the given answer. All right, so that was question number 8 for you. Next, we go to question number 9. Now, what does this question say? It says, imagine a new planet having a density twice as of the Earth. So, if this is Earth having a radius r and having density rho, now we have another planet having twice the density of Earth and 27 times bigger than the Earth in volume. Now, guys, to some of you, it might already click that if the volume is 27 times, then the radius would be 3 times. Okay, and the density is given twice. I used this relationship here that let's say if 4 by 3 pi small r cube, small r represents the radius of this, let's say. So this is 27 times 4 by 3 pi capital R cube. So 4 by 3 gets cancelled. So R is actually 3 capital R. So, since you guys have been practicing a lot of questions, I think this would strike you, this should strike you the moment you read 27 times. Okay. Now, how do we write the gravitational field on the surface of a planet? We can write it as 4 pi g. Okay, 4 pi g into density into radius by 3. Okay, so the value of g is proportional to the product of density and the radius, and here that product has become 6 times of the initial value. So we can expect the new gravity at the surface to be 6 times of the previous value. So option C would be the correct one. Okay, next we go to question number 10. Now, this question says a uniform solid sphere and a uniform solid sphere cylinder, not necessarily on the same amount of radius, are at the top of the common inclined plane release. Friction is not sufficient. Friction is not sufficient to allow pure rolling. So, guys, when you release a round object, whether it is a disc or a ring or a sphere or a cylinder, if the friction is low, Okay, then if it is absolutely frictionless, let's first talk about what happens that if it is absolutely frictionless, if mu equal to zero, then this object simply slides down upon releasing. It simply slides down. There is no rotation, which means that if the spokes were like the spokes always maintain their position. So it is only sliding down, and it is sliding down with an acceleration of g sine theta. Okay, but if there is friction, but it is not good enough to support pure rolling, in that case also it slides, it rotates also. Okay, it rotates also, but it slides, slipping is taking place, and therefore the acceleration is g sine theta minus mu g cos theta. Now, if you notice, this expression is not dependent on the shape of the object, whether it is a disk, a ring, a hollow cylinder, or a solid cylinder, or a sphere. Okay, so the question says that the ratio of the time taken by each to travel down the incline depends on mass, only radii. It neither depends on because the acceleration will be same for both, and we are releasing them from the top of the common inclined plane. So they are traveling the same distance. Their acceleration is going to be same, so they will cover the distance in the same time. Okay, and therefore the ratio of the time taken would become one. Okay, and it will not be governed by the masses or the radius. Okay. Now, question number 11. Now, guys, to do these questions, there is actually if you remember the formula, you can do it. If you don't remember the formula, you'll have to derive it. I will first mention you the formula. So, if this is charge Q1, if this is charge Q2, and they both are positive, and then we are looking for null point. Okay, they are separated by R. So, if we are looking null point from charge Q1, then the location of null point is given by, see, the more this charge is, the farther away the null point should be because if it is midway, then this will create stronger field. So it needs to be closer to the charge of smaller magnitude. So that will help you remember what you write, and I'll tell you what the expression is. It is um, root of Q1 upon root Q1 plus root Q2 into R. Okay, so what I have learned is that the distance, the equilibrium distance is proportional to the root of the charges. Okay, and then I make use of this fact that the larger charge should have more distance from the null point. So therefore, when I'm trying to write R1, I will use root Q1 in the numerator and the sum in the denominator. You can derive it also. How will you derive it? So at this point, the net electric field should be zero. So this Q1 will produce electric field in this point, in this direction, which will become KQ1 by R1 square, and then this one will produce the electric field in the opposite direction. So that should also be equal to this so that they cancel out each other. So that would be KQ2 upon R minus R1 square. Now R gets cancelled and you can work out the math. And from here we get this result. I'm directly using this result for now. So one of the charges 169 and the other. So this is root of 169 is 13. This is 14. So okay. Uh, So I will substitute root 169. Root 169 would be 13 here. Okay. So okay, let me do it here. So 13 divided by 13 plus 14, that is 27. Into the separation between them. Separation between them is 54. So this becomes 2. So this becomes 26 centimeters. So 26 centimeter from the 169 coulomb charge because for Q1 I used 169. Okay, so 26 centimeter from the A option will be the correct one. Okay, so that was question number 11 for you. Now we go to question number 12. Now, this question number 12 is based on two concepts. It is based on the concept of Wheatstone bridge, and at the same time, it is based on the concept of maximum power transfer theorem. Okay, so if you look at this part of the bridge, this part of the circuit, you can clearly identify that we are dealing with a Wheatstone bridge, and because it's a Wheatstone bridge, okay, so we can remove this, and then we can think of the remaining circuit. So 3R and 9R, they are connected in parallel. So 3R into 9R divided by 12R. So that becomes 4. So that becomes 9R by 4. So the equivalent of this entire circuit is 9R by 4. Now the maximum power transfer theorem suggests that if you want to give any resistor a maximum power and you are allowed to change that particular resistance, then you choose its value so that it matches with the internal resistance, and that way battery will be able to deliver maximum power to that external resistor. So here our intention is to maximize power developed here. So how to do that? We should equate the equivalent value of this to the EMF of the battery. Now, how much is the EMF of the battery? Here it is, sorry, not the EMF, the equivalent resistance. Here it is shown as 10 ohm. So what we are going to write is that 9R by 4 is equals to 10. And from here we get the value of R as 40 by 9. So A option will be the right one. Okay, students. So that is A option. Now we go to question number 13. So this says two parallel plate capacitors whose capacitors are 3 and 3C are joined in parallel. So This is a capacitor with capacitance C. This is another capacitance with capacitance 3C. And we join them connected. They are charged to the potential difference B. So now, if they are charged to the potential difference B and they've been charged by the same source, so obviously the same plate will have the positive charge. And like this is the situation. So, and because we have used the battery of voltage V, the charge on these are going to be on the upper one, which has the capacitance of C, it would be CV, and here it would be 3CV. So this is how the charge is going to be. Now, if the battery is removed and the dielectric constant K is found between the plates of the capacitor, then what will be? So when you remove the battery, all right, and so basically now uh, you have removed the battery, okay, and then we are inserting a dielectric here. The moment you insert a dielectric, the capacitance here becomes Kc. Okay, so now the total charge present on this plate and this plate, it has to redistribute itself. Okay, so the total charge is 4 CV, and it will get divided between the two capacitors such that they both have the common potential difference across their plates. Okay, so whatever is the potential difference across here, the same will be the potential difference across here. Uh, okay, that means if I think about Q is equals to delta V into C. Okay, uh, so the amount of charge that will be there on the plates ultimately, it will be proportional to the capacitance. Okay, so if I'm trying to write charge on the upper capacitor, I will write uh, the total charge that needs to be divided into the capacitance of the upper capacitor of the upper one. So this is 3. This would now become actually Kc. This would now become Kc divided by Kc plus 3C. Okay, so this is the charge. Now, to get the potential, the new value of the potential across this, we need to divide by its own capacitance, which is Kc. So this Kc gets cancelled, and then C gets cancelled. So 4V upon K plus 3. 4V upon K plus 3 would be the right answer to this question. I hope this is understood by everyone. Next question is question number 14. So what does this question say? Non-conducting disk having uniform charge Q is rotating about its axis. Okay, so there is a non-conducting disk like this, and it has a charge on its surface, and it is rotating. So, uh, because of its rotation, any charge present at on a certain distance, it will also begin to rotate, and it will create a situation like a current carrying loop because the charge will start moving in circles now. Okay, so let me draw a larger figure here. So we need to find out the magnetic induction at the center of the disk. So how we are going to do that? Let us assume at a distance x, there is a ring of width dx like this. Okay, so the charge on this disk would be written as surface charge density into the area. Area would be written as circumference, which would be 2 pi x into the width dx. So this is charge. Okay, now current would be written as charge into omega by 2 pi. So this would become sigma 2 pi x dx into omega by 2 pi. So the 2 pi gets cancelled, and therefore, the value of current is sigma omega x dx. Now, because this current is in a circular coil, so the magnetic field at the center would be mu naught into di by 2 times of radius, and radius would be x. So it would become mu naught by 2 di by x. Now, this is di by x will become sigma omega dx. So you can now directly integrate it. So you can integrate from 0 to r. So this will become mu naught sigma omega by 2 into r. Now, the question is that we have not been given the value of sigma, rather, we have been given the value of q. So q divided by pi r square will become sigma, which means that if we are to substitute the value of, let's say, sigma, then we can write it as mu naught omega r by 2 into q divided by pi r square. Okay, divided by pi r square. So from here, one r will get cancelled, and you will get what you will get. It would be mu naught omega q by 2 pi r, mu naught omega q by 2 pi r. Option D, we have already seen that that would be the correct option. Okay, now coming to question number 15. Now, the question number 15 says in the given circuit, the ratio of I1 to I2 is K, where I1 is the initial current that is at T equal to 0, and I2 is the current after the at the steady state. Now, guys, the question clearly doesn't mention that what is the initial, initial instant. I guess because there is a switch, then that this should be the t equal to zero. And if you don't consider this, then any other thing will not make any sense. Okay, the question becomes nonsensical then. So let's consider that. Now, the moment you close this switch, the current flowing through the battery will be considered as I. Now, keep in mind, guys, that the moment you close the switch or the moment you make any changes in a circuit, and if that circuit conducts carries an inductor, then the current flowing through the inductor, it doesn't change automatically unless you are changing the inductance of of the inductor suddenly. Unless you are doing that, the current flowing through the inductor is not going to change all of a sudden. It will change gradually. So the moment you close the switch, this inductor had zero current through it before that event of closing the switch. So it will have zero current afterwards also, like just afterward. Later on, the current will build in it, but just after closing the switch, the current in this branch would be zero, which means that the current will flow through this branch. And how much that current would be? That current would be it would be EMF of the battery divided by 4 plus 6. Okay, EMF divided by 4 plus 6. Now, a long time after, an inductor starts behaving as a conducting wire. So after a long time, this is just behaving like a conducting wire. So this 6 and this 6, they are connected parallelly to each other. So the equivalent value is 3, and 3 plus 4 is connected in series. So the next current would be E divided by 7. Okay, now see, we are not supposed to find out the value of K, rather, we need to check that K will depend on what will factor. So the value of K changes if the EMF of the battery is changed. That is not right because when you take the ratio, the E gets cancelled. So even if the EMF is different, the value of K will not change. Okay, so we are going to look for correct alternative. So this is wrong. The value of K changes if the coefficient of reductance. Again, this is wrong. The coefficient of reductance doesn't play any role. At t equal to 0, we treat this branch as an open circuit. And after a long time, we consider this inductor as a connecting wire. So nothing changes. So that is wrong. And the value of K is independent of the EMF of the battery as well as the coefficient. So this is correct, guys. This is correct. The value of K is independent of the EMF, but depends on the coefficient of. So this is wrong. So option C would be the right one here. Okay, that was question number 15. Now we go to question number 16. Now this says a pure resistive circuit element X when connected to an AC supply of peak voltage. So there is an AC supply. The peak voltage is, let's say, 200 volts. So this is a peak voltage. So something like 200 volts sine omega t is what we can expect for EMF. Now we have connected it with a pure resistive element X. Okay, and the RMS current that we get is 5 ampere. So 5 should be equal to 200 divided by the resistance of this. So let me write it as XR. Okay, this is the peak value. So peak value upon root 2 is the RMS value. So the RMS value of the current was 5. So I found it out. And from here we get the value of XR is how much? It is 5 into 40. 40 by root 2. So that is 20 root 2. Okay, this is 20 root 2. Now it's the question says that a second circuit element Y when connected across the same AC also gives the same RMS current. So but it lags behind. So that means the next circuit element that we are talking about, Y must be an inductor because the current is lagging now, okay, by 90 degrees. So it should be an inductor. So XL should have the same value as XR because this XL was giving the same value of, the peak value. The peak value of the current was given to be same. So therefore, these two needs to match. If the series combination of X and Y is connected to the same supply. Now, if X and Y are connected in series, the value of Z is going to be root 2 times of XR. Okay, because what you would be doing, like let me do one more step before this. So you would be doing this XL square plus XR square, and you check this. When you put these numbers here, it becomes root 2 times of R, which is actually 40. Oh, yeah, 40. Root 2 times of R. R is 20 root 2. So it becomes 40 ohm. Okay, now the question is asking what is the RMS value of the current now? So the RMS value of the current now would be 200 is the peak value. Let's divide it with root 2. So that becomes the RMS value of the EMF. We would divide it with Z. Okay, so this becomes 5 by root 2. So this is our final answer. So option B would be the right option here. Next, we go to question number 17. It says a prism having a refractive index of 1.6 has the minimum deviation equal to the. Now, we are talking about minimum deviation, and the equation that governs the phenomena of minimum deviation is this mu sine A by 2 is equals to sine of A plus delta minimum by 2. The question says that minimum deviation is equal to the refraction angle of the prism. So, mu sine A by 2 will be equal to sine of A plus A by 2, that is A. Now this sine A can be written as 2 sine A by 2 into cos A by 2. Now what happens is that this sine A by 2 gets cancelled and therefore cos A by 2, it becomes equals to mu by 2. What was the value of mu given to us? 1.6. 1.6 by 2 will become 0.8. So A by 2 is 37 degree because cos 37 is 0.8. So A is 74 degree. So the prism angle is 74 degree. Option B would be the right answer. All right, that was question number 17 for you. Next, we go to question number 18. Okay, guys. Now the potential energy here, the potential energy between electron and proton resistance R is given by this. So it is given as minus Ke square by 4R square. So this is the potential energy. The force would be given by minus du by dr. All right, so minus d by dr of minus Ke square by 4R square. So you can see that the minus sign will is going to get removed from the situation. So it will become derivative of Ke square by 4. Out of this also K square by 4 can be taken out as a common quantity. So now we are talking about differentiation of 1 upon R square or R raised to power minus 2. So this will become K square by 4 into R raised to power minus 2. So minus 2 will come here and then R cube it will become. No, I think I missed out on something. It was R4 actually, a bit of oversight. This was 4. Okay, so this will be 4 and this will also be 4, which means R raised to power minus 4 derivative. So here we will be having a 4 and this would be 5. So this gets cancelled. So the force is minus Ke square by R raised to power 5. Now, whatever this force is, Ke raised to power 5 upon no, Ke square actually upon R raised to power 5 is equals to mv square by r. One r gets cancelled. So from here you see that v square is some constant times r square, or they are inversely proportional. Okay, r and v, they are inversely proportional to each other, because I can further write it as that v is equals to some constant by r. Now that is one equation. The other equation is the quantization equation, quantization of angular momentum. Mvr is equals to nh by 2 pi. Okay, so we are trying to okay, so that becomes our second equation. Now, what are we trying to find out? We are trying to find out about the total energy, the potential energy. So we are the options talk about the total energy. So how do we write the total energy? The total energy will be written as potential energy, which will be nothing but this only. So it would be minus Ke square by R raised to power 4 plus half mv square. Okay, guys, I think there is a little bit of again oversight. This is 4 actually, and therefore this will not be right. So, okay, this is v square equal to c by 4. So here we get v square, and v square can be written as c by r raised to power 4. In other words, the total energy is, you know, it's coming out to be proportional to 1 upon r raised to power 4. All the other things are constant. This is the total energy. Okay, now pay attention to one thing. Uh, from here, can I get R in terms of N? All right, so if I square the both the terms, so even the square of this will come. Okay, let me change the pen color. Now from here I see a V square is here. V square is proportional to 1 upon R raised to power 4. So 1 upon R raised to power 4 I can bring here. So this will become, like you can see here, that what we will get is 1 upon R square is proportional to N square. And therefore T would be proportional to N raised to power 4 because of this relationship. So T would be equal to, so option A would be the right answer. Okay, that was question number 18. Now we go to question number 20. In a photoelectric effect, the frequency of the light used. Now, guys, in a photoelectric effect, the intensity is dependent on the number of photons incident per second multiplied the energy of the one of the photon. Okay, so this is the power actually, and we decided divided with area, baby. Okay, now we are making some changes to the number of photons to the frequency. So I'm writing the new intensity as n prime h. H is the universal constant into nu prime by a prime. Okay. Now question says that the new frequency is doubled. Okay, so n prime h into 2 nu. Okay, and I prime. Okay, it says that the intensity becomes half. So I prime is actually I by 2. I prime is I by 2. Okay, so from here, notice that if I divide the two, like if I divide I by 2, it is same as nh by nu upon a divided by n prime h into 2 nu and then a prime. A prime would be same as a again. Okay, so the a gets cancelled. Okay, the a gets cancelled. The h gets cancelled. Okay, the nu gets cancelled. So we are left with n upon n prime into 2. This is 2. Or in other words, n prime is n by 4. So because the total number of photons has decreased, so therefore the saturation current will also decrease. The total number of photons has the uh, total number of photons is decreased by a factor of 4. So the saturation photocurrent will also decrease by a factor of 4. Okay. Yeah. So the saturation remains current. This is wrong. Maximum kinetic energy also gets doubled now. Again, that is wrong. Why? Because kinetic energy earlier was h nu minus phi. Now the kinetic energy would be h into 2 nu minus phi. Now this is not the double of previous. Okay, like it's not like as if they are double of one another. So this is wrong. Okay, so both statements are wrong. Okay, so here option D would be the right answer. Okay, next we go to question number 20. Now, this question says in a Young's double slit experiment, the central maxima is observed to be I naught. Now, the intensity of the central maxima is actually four times the individual intensity. Okay, assuming that both the slits are producing the same intensity I1. Okay, then at center you get the intensity which is four times of I naught, I1, which is right now given as I naught. So, this is a relationship. Now, if we make one intensity half, then the maxima will still be found at the center. Now, the intensity at the maxima would be root I1 plus root I2 and square of this. So this will become root of I1 by 2 plus root I1. All right, square of this. So this is what? Um, this will be the new intensity actually, and this is what? I1 by 2 plus I1 plus 2I1 upon root 2. Okay, so this becomes 0.51, 1.5, and this is 2 by root 2 is 1.4. So 1.5 plus 1.4 is around 2.9 I1. Okay, we want to answer in terms of I naught. So I can write 2.9 into I1 can be written as I naught by 4. Okay, so we are looking at a number which is close to zero point 0.7. So B option would be the right one. Okay, so that was question number 20. Now we move into the numerical section. Now in this question, the depicted container has two tiny holes at height of 7h by 14 and 3h by 4 measured from the ground. Now let's see, this entire height is h. This entire height is h. So 3h by 4 would be somewhere here. It is made also. So this distance would be h by 4. Okay. Now, and the other hole is here where this distance is given to be 7h by 16. Okay. Now, guys, understand one thing that the liquid coming out from the top, there's a difference between the two situations. Liquid coming from here. Here, what is happening? If a liquid is coming out, then at above this point, above this hole, it's only that kind of liquid. There is no other kind of liquid. So in this case, the velocity of efflux would be root 2g into h by 4. So that would be the velocity of flux. Now here, if you want to use this formula, what you need to do, you can't simply, check this height and use it in the efflux formula. You can't do that. You shouldn't do that because the liquid has changed. So what do we do? See, this is a liquid of density D. This is a liquid of density 2D. So we will replace this thickness of liquid. Okay, we are going to replace this with another thickness, maybe which we don't know yet, but which has a density 2D. And this thickness will be decided on by the logic that whatever pressure this D thickness was exerting, the same pressure this two this whatever pressure this h by 2 thickness was exerting, the same pressure should be exerted by the thickness of y. So the pressure was how much? Like it was rho g into 2d. From here we have written the pressure, and from here it should be equal to rho g h by 2. Okay, so rho g gets cancelled. So the value of d is h by 4. Sorry, not the value of d. What I'm writing. Just a minute, guys. Uh, Rho g. Guys, just a minute. I made some mistake here. Okay, so the pressure of this layer would be rho into 2d into y, and the same pressure should be exerted by this layer. So it would be written as rho g into h by 2. Yeah, that would be the relationship. So from here, y is equals to what? Rho g and rho g gets cancelled. So y is h by 4. Once you know the value of y, then what you can say that we have replaced this d liquid with another liquid of density 2d. So from above this hole, now we have a uniform density up to what height? Up to a height of, let's say, h by 2 minus 7h by 16. Okay, so that is this height plus y. Okay, so plus h by 4. Okay, so root 2g into this entire value. This is the velocity in the next case, and now we can take the ratio. The question asks us to take the ratio. So, okay, let's first calculate this. Okay, so this will become root of 2g. Obviously, we can pull out h as the common quantity, so h will become the common quantity, and this will become what? Um, h by 2 plus h by 4 is 3h by 4. 3h by 4 minus this. So that would be 12. 12 minus 7. So 5h by 16 is what we are going to get. Now, if you take the ratio, okay, so 2g and 2g are going to get cancelled. H and h are going to get cancelled. So 16 by 5. 16 by 5 and then into 1 by 4 root of that. So this is what? This is 2 by root 5 and therefore the value of k is 5. The value of k will become 5. Okay, now question number 22. This question says an ideal gas is taken through a process in which the pressure and the volume varies. Now notice that this form represents a polytropic process, which can be written as PV raised to power minus 4 equal to K. And for any polytropic process, the molar head capacity can be written as CV plus R upon 1 minus alpha. The question exactly gives us the same expression. So from here, it is clearly evident that K is actually 1 minus alpha. All right, and alpha in the present scenario is minus 4. So the value of K is actually 5. Okay, so that would be the right answer. Okay, next we go to question number 23. It says a barometer. This is a very good question, guys. A barometer is faulty when the true reading. So, guys, a barometer is there, and usually, what kind of fault is there? Usually, the fault is that some air enters into the barometer. So, this is a barometer of length L. All right, and let's say it has got some liquid filled in it, and we see that the height of this liquid right now is 68. Okay, it's 68. So ideally, like right now, it is not vacuum here. There is some air, and this air is producing P1 pressure. Otherwise, in a correct barometer, there should be vacuum here. Because of the presence of P1, the liquid has gone down a bit. Ideally, it should have been at 72 because that is the true pressure, but it is right now at 68. So the gas has pushed it down. Okay, so by how much the gas has pushed it down, or what? How much is P1? It should have been 72. It is 768. So this has been pushed down by an amount of 4 centimeter into density of the liquid into G. So that is P1. Okay, the same logic you can apply for the next case also, that this height, this height became 70 when this should have been actually 75. So in next case, in the next case, this P2 changes to P1 changes to P2, where P2 will be written as the difference of 75 and 70, which is 5. So 5 centimeter into rho into G. Okay, now notice this. Notice this, that uh, the air here, we can assume that the temperature of the air remains same. So we should be able to write P1 V1 equal to P2 V2. Now, what was V1 initially? Okay, the P1 we know P1 is 4 into rho into G. How about V1? So V1 would be this length into the cross-sectional area. So cross-sectional area, let it be A. What about this length? This length would be the actual length of the tube, that is L, minus whatever was the reading. So initial reading was 68. All right, so when we were writing the P1 pressure, the reading was 68. So this much. Next, the P2 pressure is 5 into rho into G, and then area, and then what? So when we are talking about P2, this length changed to 70. Okay, this length changed to 70. So we would be writing L minus 70 here. So let's solve this. So things are going to get cancelled. Rho G and A, they're going to get cancelled. So it will become 4L minus 4 into 68. So 4L minus 4 into 68 is equals to 5L minus 5 into 70. So 4L minus, so this becomes L is equals to 350 minus 4 into 68, that is 240 plus 20, 8, 432 to 272. So 28 plus 50 is 78 centimeters. So the correct length of the tube is 78 centimeters, as you can see here. All right, fabulous question. Good question. Okay, next we go to question number 24. Now, this question is a simple application of the work energy theorem. This block has been projected with a speed of root k, and when it climbs and crosses this point, its speed is 4. Its speed has become 4 meter per second. So, during this process, the work done by gravity, I will write the work. Gravity has done negative work because the height is increasing. So, minus mg into change in height. So, this is 3 meter, and then 3 meter on an inclined surface. So, we can write as 3 plus 3 again, L sine 37. Sine 37 is 0.6. So this is work done by gravity. Next, we are going to write work done by friction, which will again be negative. So how do we write work done by friction? It becomes minus mu. Mu is zero point 0.5 minus mu into m into g into cos theta. Cos theta is 0.8. Okay, cos theta is 0.8. So mu mg cos theta, that's friction force, into the distance, which is L. Okay, which is 3 meter, which is L, which is 3 meters. So this is the work done by friction, and this should be equal to change in kinetic energy. So half m into 4 square minus half m into root 17k square, which will become 17k. Now we need to solve this. Okay, so let's do it. So m is gone. So 3 plus 1.8. So this is 1.8, 3, 4.8, 4.8 into 10, minus 48. Okay. Then from here, zero point 0.5 into 10 is 5. 5 into 2.4 is 12. Okay, this is equals to 16 by 2 is 8. minus 17K. So 17K will be equal to 8 plus, so this is 68. So K would be equal to 4. So 4, okay, I missed out something. Uh, just a minute, guys. This seems 48. Okay. Hmm. I missed out on this 2. So it would be 17 by 2, 17 by 2, and therefore a 2 will appear here. So the value of K would be 8. Okay, now that brings us to the last question of this test. The length of the potentiometer wire is L. A cell of EMF is balanced at. So we connected a cell with a potentiometer wire of length L, and then another cell balanced. Okay, a cell of EMF is, oh no. So let's say this has EP. We don't know that another cell of EEMF balanced. Okay, it balanced with a galvanometer at L by 4. All right, at L by 4. Okay. So basically, whatever is the length of the wire, quarter of that length becomes the balancing length. Okay. So now, in a separate situation, like when we have used the same battery of EP EMF, but we have increased the length of the wire by L by 2, and we have made it as 3L by 4, 3L by 2. Okay. The question says that we increase the length by L by 2. All right. So L plus L by 2. Now, when we connect the same battery E, okay, then again the null point would be found at 1 by 4th of the original length of the entire length. So 1 by 4 of 3L by 2 is how much? So we can expect null point to be at 3L by 8. That is 1 by 8. So 3L by 8, and we are looking for 3L by K. So the value of K will be equal to 8, and that will be the right answer. Now, this brings us to the close of the discussion of physics section of Eklavya Scholarship Exam 2. All right, I hope you enjoyed the solution, guys. I hope you're going to make maximum benefit out of it. And do write the third test, guys. I think you're going to enjoy these tests a lot. All right, take care, everyone. Bye bye. All the best.
Now let us start discussing the chemistry portion of your Eklavya entrance test 2. Yes, this was the very first question of your Eklavya entrance test, which is from isomerism GOC part, and I'm sure you did it right because it is based on CIP rules, EZ naming of geometrical isomers. So which of the following compounds has Z configuration? So you are supposed to figure out the compound with Z configuration, right? And Z, in Z configuration, the higher priority groups, they are on the same side of the double bond, right? So let us quickly check which is Z out of all the options. Okay, guys, this is the very first molecule. So these are the two. So this is the first priority group. This is the second priority group as per the CIP rules, Kahn-Ingold Prolong rules, right? And of course, this is first and this is second priority. So it is highest priority there, diagonally opposite side. That means it is E. Let us discuss this. This is the first priority and this is the second priority on this carbon, and on this carbon this is the first priority, this is the second priority, as you can see. So this is Z. So we got our answer as Z, but still we can check the further ones in bromine and chlorine. So bromine is the first priority, chlorine is the second priority, right? You can check it here, and of course out of these two you can see this is the first priority and this is the second priority. Again it is E, higher priority group, they are diagonally opposite, right? So let's see the fourth option. What is the fourth option we have? So the fourth option that we have is this, right? This is the fourth option that we have. So guys, as per this, again this is first priority, this is second priority, and out of these this is the first priority and this is the second priority, right? So again it is E configuration. So only B was there, which is Z configuration, and we are supposed to mark the Z configuration molecule, that is B. For this we are supposed to know the CIP rules, that the more is the atomic number, more is the priority, and if there is a double bond, that means this has double or triple bond, that also because it is there, it is equivalent to this, right? And if it is a triple bond, it is equivalent to this. So you should know how to figure out the priority as per the CIP rule. So the answer that we will mark here is indeed B. B is the correct answer, guys, as per CIP rules. Higher priority on the same side of the double bond. Next, let us move on to the next question. Consider the following reaction. So you can see there is this reaction. We can see the ethoxy group, OR group here, right? And there is this double bond with CHO, ammonium nitrate, and you can see, okay, one is this becomes carboxylic acid and we can get this acetal. We call it acetal, right? Acetal. So there is a kind of acetal formation. You can see this C right? So there is an acetal formation on this carbonyl, you can see CHO, this is the carbonyl, and as per the reaction, if I can figure out, this is becoming what? It is becoming acetal formation. OR on your carbonyl carbon, right? So there is an acetal formation reaction, but this is not the usual acetal formation reaction that we generally do, right? Using the two molecules of alcohol with one molecule of carbonyl compound. This is not the usual acetal formation reaction, right? So what answer we will mark here is, this is a kind of rearrangement reaction. This is the oxidation reduction reaction. This is not an acetal exchange reaction. This is an entropy supported reaction. Compared to the conventional acetal, yes, it is not a conventional acetal formation where like we use two molecules of alcohol and one molecule of carbonyl, that is three molecules of the reactant that is giving two molecules of the product. Here we have two molecules here and we got two molecules of product, so we will definitely mark it as D donkey. You might get confused in this. Yes, this is something that you will find as a reaction in many like foreign author books like Clayton when you read the acetal formation from those books. So this is the reaction, guys. This is the reaction. Yes. So I will mark the answer, and I'm sure if you did it right, you marked it D donkey. Let's move on to the next question. Question number 3. Identify the incorrect statement. So if such question comes, please be very mindful, very careful what they are asking. Correct, incorrect. So in chromyl chloride test, formation of chromyl chloride. I hope you all know chromyl chloride test, right? So we use dichromate, potassium dichromate along with some acid, and if there is a chloride ion, chromyl chloride test is used for the detection of chloride ion. So if we have a species having chloride ion, if we have a salt having chloride, Cl negative ion, if we add potassium dichromate along with some amount of H2SO4, concentrated H2SO4, there is a formation of red vapors of chromyl chloride, that is CrO2Cl2, right? So the first statement is indeed the correct statement, because in potassium dichromate and chromyl chloride, the oxidation state of chromium remains the same. So first is the correct statement. The Brown ring test of NO2 negative can be done in the presence of nitrate, but the Brown ring test of nitrate cannot be done in the presence of nitrite ion. So both give, nitrate and nitrate, they both form ring. Ring formation is there in the Brown ring test, but nitrites are more reactive than nitrates. So if both the ions are there, and if we want to detect nitrate, of course they will react first and form the ring, and we'll get to know nitrate ions are there. But if we want to detect nitrate ion, and already nitrate ions are there, so if we add the reagent ferric chloride H2SO4, so the nitrite will first form the ring in place of your nitrate. So of course this is also a true statement. The reason, nitrite being more reactive and the both ions will give positive test, they will form Brown ring formation in the test. Next, chromate and dichromate ion can be interchanged by modifying temperature. Of course not. This is very wrong statement. I am sure you know pH can affect which ion will exist, the equilibrium will shift in which direction, right? So I hope you know, if the pH is acidic, your chromate will get converted into dichromate. So it is a kind of pH driven. In acidic and basic medium, different ions will exist. So borate can be detected by using calcium fluoride along with concentrated H2SO4 without touching the flame. This is also correct. So we are supposed to figure out the incorrect statement, that is indeed C. Yes, and very easy to figure out the incorrect statement here, because very obviously whenever we do transition elements, we study about potassium dichromate. We do this, chromate ion is yellow, dichromate is orange, and how the pH affects their, their presence in the solution. Okay, so 2 moles of helium gas can undergo a reversible cyclic process as shown. So we have a reversible cyclic process. I can see the P versus T is given here. Okay, what is the net work done in the cyclic process? So if I have to figure out the net work done, I will just convert this graph, which is P versus T graph, into PV graph, because area under PV graph will give me the work done in the entire cyclic process. So first I am going to convert, and then I will use my usual equations of calculating work done for each step. So A to B, it is an isothermal process. The temperature is constant, pressure is increasing. So pressure is increasing, temperature remains constant, and we all know PV is directly proportional to T. If T is constant and P is increasing, that means volume has to be, you know, decreasing. Then only the T can become constant. So when I go from A to B, right? A to B, the volume should decrease. So say this is my point A, this is my point B, and the volume is decreasing, and of course the pressure is increasing. Now from point B to C, you can see the pressure is constant, that is isobaric process, and temperature is increasing. Temperature is increasing, pressure keeping constant, that means volume has to be increased, right? So from going B to C, I should increase the volume. This is my point C, right? Now from C to D, again isothermal process, right? Because the temperature is constant and the pressure is decreasing, that means volume has to increase. So this is my point D, and it is a cyclic process, so I will definitely join these. So this is the PV graph, and now area under this PV graph, this area will give me the work done, right? Yes. So now the total work done, if I have to calculate the total work done in this process, that is the work done from going A to B, plus work done going from B to C, plus work done going from C to D, plus work done going from D to A, right? Now let us look at the table. A to B, volume we don't know. B indeed knows the value of pressure. This is 1 atmosphere. This is 2 atmosphere, right, from this graph. Now guys, just look at the graph A to B, right? A to B, if you are going A to B, that is an isothermal process, right? Isothermal process. So we are going to use the equation of work done minus nRT log of V2 by V1 for isothermal processes, right? And for isobaric processes like B to C or D to A, will use work done is equal to minus P delta V, right? Minus P delta V, that is we are going to use P delta V equations we are going to use for BC process and DA process. For process AB and DC, because both are isothermal, we are going to use the isothermal equations, right? Now the point is, what is V1, what is V2? So I am supposed to calculate what is this V1 and what is this V2, or you can say what is this VB, VA, VC and VD. So how can we calculate the volume values? Of course, by using PV is equal to nRT, right? Yes. So for this, we know pressure 1 atmosphere, nR, we have 2 moles of helium gas, so N is 2 here. Temperature at point A is 300 Kelvin. So we can calculate VA, the volume at A. Similarly, we can calculate VB by using PV is equal to nRT by P. So we can use the volume VA, we can calculate the volume VA, VB, VC, VD, right, by using the ideal gas equation. And then once we get the volume, we can simply apply the work done equation for isothermal process. This is isothermal and this is also isothermal and they're isobaric. So we use our standard equation that I'm sure you know, they're very important, especially the isothermal one, frequently being asked in JEE. So guys, make sure that you know those equations. Just put the value. I am sure you will get your answer correctly if you don't do any so-called silly mistake. So the answer will be A. So you can check, guys. You can check here. Volume VA is 600 by R, VB is 300 R, VC is 400 R, and VD is 800 R by using PV is equal to nRT, right? AB minus nRT log of V2 by V1. BC, because it is isobaric, minus P delta V, V2 minus V1. CD, again isothermal equation. AD, again isobaric equation. Just add, you will get your answer as minus 100 R ln 4. Right, guys? So I hope you did it right. That might be a bit time consuming. You must have spent a good amount of time to get your answers right. Okay. Now 40 ml of a solution of oxalic acid. We have a solution of oxalic acid which is given X molar. Molarity is X. Requires 16 ml of 0.05 molar acidified KMnO4. Calculate the pH. Okay. So we are supposed to calculate the pH of 2x molar solution of oxalic acid and Ka is also given to us. Right. So what we are going to do? Simple law of chemical equivalence. The equivalence of oxalic acid, because they are completely reacting each other, is equal to the equivalence of KMnO4. Right. So the equivalence of oxalic acid is molarity, that is X, into volume, that is 40, into valency factor. So molarity into volume into valency factor. Here the equivalents of KMnO4, the molarity, that is 0.05, the volume, that is 6 ml. I'm using the same unit of volume on the both sides. And of course the valency factor in acidic medium for KMnO4, I hope you are very much aware, that is 5. The valency factor of KMnO4 is, or in fact for the region, that is dependent upon the medium. So in acidic medium it is 5. I'm sure you all must have remembered it as band 153, right? So this is how we can get the value of X. Solving this, we can get the value of X. What is X? X is the molarity of our oxalic acid, right? So this is 80, that is also 80. So X will come out to be 0.05 molar. Now we are supposed to calculate the pH of 2x molar oxalic acid solution. Please be very careful that they are asking us the pH of 2x, right? So you know it is a weak acid. For weak acid, the H positive ion concentration is Ka into C, right? Now what is Ka? Ka is given to us 10 raised to power minus 3. And what is C? Concentration is 2x. It is not x. So be very careful. I'm telling you again and again. It is 0.1, that is 10 raised to power minus 2. So the H positive ion concentration for 2x is coming out to be 10 raised to power minus 2. That, if course, tells us the pH of the solution will be 2. So the pH is 2. So we will mark our answer as A for apple. That is 2. I hope you got it. Pretty simple. Just be careful that they are asking about 2x. Got it, guys? Okay, so this was the question number 5. Let us move on to the question number 6. Which of the following statement is not correct? Which of the following statement is not correct again? So orthohydroxybenzoic acid. So we have orthohydroxybenzoic acid. There will be intramolecular hydrogen bonding, because ortho, OH and COH, they are at the ortho position, and para-hydroxobenzoic acid, so they are the para position, OH and COH. So let's check ortho and para-hydroxy. So let me make it COOH and OH. This is ortho isomer and this is para isomer. So I can say in ortho we can expect intramolecular hydrogen bonding, and intramolecular, and here we can expect on para isomer intermolecular between the different molecules. Now the solubility in water. So the one which will form hydrogen bonding with water is more soluble. Now it is having intramolecular, it is happy within itself. Now this para isomer can form hydrogen bond with the solvent water. So because it can nicely bond with the solvent molecule, water molecule, via hydrogen bonding, that means this isomer should have more solubility than the ortho. So, but this is not given. So, oh my God, by taking A only we get our answer so quickly. But let us see the others also. H2O2 is more acidic than H2O2. Yes, it has more deprotonation tendency than H2O. And of course, the open book like structure is there. More bond angle, and chlorine has bigger size. Of course, the more bond angle. And triethylamine, because of course, back bonding, it has a planar. There's a back bonding, right? The lone pair of nitrogen that is being donated to the empty d orbitals of silicon because of the back bonding written in NCERT. This is planar. So of course, the incorrect one we'll go with is A for apple. Now the next one. For the following reaction, P gives 2Q, assuming the Arrhenius vector A to be constant. Again, the question in this paper also on Arrhenius equation. Activation energy to be dependent on temperature, guys. You can see temperature as, and it is a function of temperature. So you can see the activation energy is 0.04 T square calorie per mole. And if the temperature for the above reaction is increased from 200 to 400, then the incorrect options. So what are the options we have? Okay, they are asking about the rate constant, the change of rate constant value, and the activation energy, right? So this is the differential form of our Arrhenius equation. So as given in the question, EA is 0.04 T square over R T square. So this will get cancelled out. You can see, guys. Yes. And R, because the unit that we are using is calorie. Let me put R as 2, because in calorie, of course, I hope you know calorie per Kelvin per mole, our value is 2, right? So I will get this as 0.02. This. Now what I will do, I have this dl and k 0.02 dt, right? Just integrate from t1 to t2, the rate constant become k1 to k2. So just integrating, I will get ln of k2 by k1, and I integrate with the temperature T1 by T1 to T2. T2 is 400 Kelvin. T1 is this. So it will be 0.02 T2 minus T1, right? So what I will get is ln K2 by K1. I'm just putting the value. At temperature T1, the rate constant is K1. At temperature T2, the rate constant is T2. 0.02 into 200. Got it? Yes. So I will get it as 4. That means K2 by K1 is e raised to power 4. I hope you got that. So K2 by K1 is e raised to power 4. So the first statement is correct, right? Second is also correct. The rate constant, no, not increased by 4 times, it is e raised to power 4. Increases to e raised to power 4. The activation energy increases to 4 times. Of course, temperature, here the activation energy is 0.04 T square. So temperature becomes from 200 to 400. So that means your activation increases 4 times. From 200 to 400, you can put the value and check. So all are correct except C. So we will mark our answer as C. I hope you got it. A beautiful question, I will say, on activation energy. Kind of a different question, yes. Now the next question. Okay, beautiful. So it is on P block. Very important in P block, boron compound. So I can see this question because I can see diboron, boric acid and borax, all the important boron compounds in this one question. So good question from P block. So this is your borax. Okay, how your borax become orthoboric acid? How you can convert your borax to orthoboric acid? Of course, by acidic hydrolysis, ma'am. Acidic hydrolysis will convert your borax to, right? Yes. Now, how can you convert diboron to boric acid? Guys, please see, all important reactions are being used here, right? Yes, all important reactions are being used here. So what is C? Again, by hydrolysis, on hydrolysis, your diboron gives boric acid. Now from boric acid to boron, how can you convert? How can you get the pure boron from boric acid? If you heat this in the presence of magnesium or iron, right? Active. So your boric acid will get converted to pure boron. The preparation, you can say. Now your boric acid and this is basically, what is it? Ammonium. This is there, right? And your boric acid is there. Now what you will get? HF2 negative and you have a boron. So this ion will be replaced by BF4 negative ion from this orthoboric acid, right? So let us mark the answer. A is acidic hydrolysis, C is acidic hydrolysis, acid. So out of A and B, C is hydrolysis, perfect. Okay, so we'll mark our answer as B. Please check very, very important reactions from boron compounds. Please make sure that when you are going to give your JEE exam, do not forget to do P block, indeed an important chapter from inorganic, and of course boron compounds, highly supremely important, guys. Okay, those who did it correctly, well done, guys. Inorganic going good. Let's move ahead. Okay. Vapors of a substance A. Question number 9. The vapors of a substance A. The density is given to us at 500 Kelvin, 1 atmosphere. It diffuses at the rate of 4 times the rate of diffusion of O2 under the same condition. Calculate the value of compressibility factor. So compressibility factor we are supposed to calculate Z from real gas. The compressibility factor is P into molar volume by RT. So if you have to calculate the compressibility factor, guys, you are supposed to calculate temperature is given to us, pressure is, these terms are given to us. We are supposed to know the molar volume, the volume of 1 mole of a gas of this substance A, right? Then we can calculate Z. So how can we calculate molar volume? What other information is given to us? Okay, Graham's law of diffusion, because we are given the information about diffusion. Rate of diffusion of O2, you can say, rate of diffusion of O2 upon the rate of diffusion of A. It diffuses at the rate 4.5 times the rate of diffusion of O2. Rate of diffusion of A upon RO2 is 4/5. That is molar volume of O2 upon the molar mass of A. Graham's law of diffusion, and I'm sure you all are aware, right? So this is equal to, 32 by mass of A. From here, we can calculate the molar mass of A. That is the mass of 1 mole, right? From here, we can calculate Ma. That is the molar mass of 1 mole. Let's see what it will be. Scaling both sides, it will come out to be. So Ma will come out to be 16 by 25. No. 32 into 25 by 16. That is Ma. Got it? So your Ma, the molar mass of A, will come out to be 50. Right? Now we have density. Density is mass upon volume. You have density. You have mass of 1 mole, that is 50. Density is also there. Just take care of the unit conversion, guys, because you want volume in liters, right? For to use here. So just be careful with the units of volume. So volume, this is the molar volume, because the mass we are putting is of 1 mole. We know density, we know the mass of 1 mole of vapor A, and then by using D is equal to M by V, we can get the molar volume, right? The volume of 1 mole of vapors of A. So put that value here. P we know, T we know, because we are given that in the question itself. We can calculate the compressibility factor Z. And again, question from states of matter, gaseous state, using two important topic. One is real gas, the compressibility factor. Another is Graham's law of diffusion, guys. So you can see here, guys, the molar volume will come out to be 62.5, and putting that value here in this compressibility factor will be coming out to be more than 1. Got it, guys? Okay, now the question on thermodynamics. Given that the enthalpy of formation, standard enthalpy of formation of NH4Cl is given to you. Okay, delta Cp for the reaction is 0. Entropy data is given to you. Calculate the delta G naught, the Gibbs free energy change under standard condition for the formation of NH4Cl. First, let me write the reaction for NH4Cl formation. So I am supposed to make NH4Cl solid, 1 mole of it, from nitrogen, from hydrogen, and from chlorine. Okay. So this is the reaction of formation of 1 mole of NH4Cl from its elements in the standard elemental form. So you can see, so the delta HF for this reaction is given to me. And I'm supposed to calculate delta G naught. So delta G is equal to delta H, that is given to me, minus T delta S. But be careful, all the data here is provided at 300 Kelvin, and they're asking us to calculate delta G at 310 Kelvin. Whatever data is given, that is at 300 Kelvin. If the data is also at 310 Kelvin, we can simply put the value, because everything is given. All the values are given. Delta H is given, delta S. How can I calculate delta S of this reaction? Delta S naught of this reaction, sum of delta S naught of products minus the sum of delta S naught values of reactant. So everything is given. We are provided with the delta S naught of this, 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 and this. So product values minus reactant values, we can calculate delta S naught F for this reaction, right? Formation of NH4Cl, we can calculate delta S for the reaction. Now, guys, the point is, the data is at different temperature, and we are supposed to calculate delta G at a different temperature. Now the roles of this heat capacity at constant pressure for the reaction is 0. Please have a look. Delta S is NCP delta T. If delta Cp is 0, that means delta S is also 0. That means entropy delta S at, there is no change in entropy, at 300 Kelvin is equal to the value of this at 310 Kelvin. Same, you can see Kirchhoff's equation here, guys. Kirchhoff's equation, delta H2 minus delta H1, T2 minus T1 is equal to delta Cp. This is 0, that means delta H2 is equal to delta H1. That means by using Kirchhoff's equation, we can prove the enthalpy of formation at 310 Kelvin is also equal to now 300 Kelvin. Now, no issues. We can use this data as such because at 300 Kelvin, at 310 Kelvin, the entropy changes same, enthalpy changes same. So we can use this data. We know delta H at 300 Kelvin, that is same at 310 Kelvin. Temperature 310 Kelvin, delta S we can calculate using this equation. Putting the data, I'm sure you can get. The only trick point here is the values. The data is given at some different temperature and they are asking us the delta G for another temperature, providing delta CPR for the reaction is 0. So that is the trick part of the equation, guys. You should know if delta Cp is 0, there is no change in entropy, there is no change in enthalpy. So the answer that will get from this question is A. Please, you can check the values if you do any kind of mistake, any calculation mistake that you, though the calculations are not much, the answer is this. Question number 11. Ammonia at initial pressure of 15 atmosphere and 27 degrees Celsius is kept at 347 degrees Celsius. When decomposes, equilibrium is established. Perfect. At equilibrium, the total pressure is found to be this. First, let me write the decomposition reaction of ammonia. So the reaction involved here is 2NH3 on decomposition gives N2 plus 3H2. Right? Done? Okay. Now the total pressure at the equilibrium is given to us and basically degree of dissociation of ammonia that we are supposed to calculate. Alpha we are supposed to figure out. Right? So let's do the standard way. Initially or at equilibrium. So initial concentration is C. That is the initial concentration, right? And 0 and 0, right? And this will be at equilibrium C1 minus alpha. So alpha moles are dissociating, C alpha moles are dissociating. So I will get C alpha by 2 because 2 moles of ammonia give 1 mole of nitrogen. And similarly, got it, guys? Please check, guys. This is how we do. Okay, now total moles at equilibrium. If I talk about total moles at equilibrium is the sum of all these values. C minus C alpha plus C alpha by 2 plus 3C alpha by 2. Yes? Please check. That is C plus C alpha. Total moles at the equilibrium. Done, guys? Yes. So let's use the equation. Initial pressure is given to us. So PV is equal to nRT. PV is equal to nRT. You can see here. PV is equal to nRT. At temperature T, pressure is 0 initially. So initially pressure is 15. Volume is V because we are not aware of volume. Moles, you can say C moles, right? You can say C moles. If I take them as moles to make the things simpler, right? Okay, now let me write initially P, volume V, moles A, R, and the temperature, of course, 27 degrees Celsius, right? The initial temperature was given 27 degrees Celsius, that is 300 Kelvin, right? This is the one equation. Another equation I will write at the equilibrium. Again, PV is equal to nRT at equilibrium. Now at equilibrium, the pressure is 50. The volume of the container remains same. The moles C plus C alpha, R, and the temperature is 347 degrees Celsius. Please do not forget to convert the temperature in Kelvin, right? So you have two equations, equation 1, equation 2, right? So by using this, you can take it as whatever, right? The better term to use for moles is A, or X you can use, right? C generally we use for concentration, but as I started the question by taking C, you can take it C. So guys, you have to equation 1 this, another this, dividing the two, I hope you will get the value of alpha. V gets cancelled, C gets cancelled, R will get cancelled. Just divide the two equation, you will get the value of alpha. So we approach this question in the standard manner. Initial moles, equilibrium moles, by using P is equal to nRT at initial condition. This is initially and this is at equilibrium. Got it? Dividing the two equations, you'll get alpha, that is the degree of dissociation. I hope guys you do it the same way and you get your answer correct as 0.613. You can check here if you do any kind of mistake, guys. 0.613, that is the alpha. Around 61% is the dissociation of ammonia in this question, right? Okay, let's move ahead. Okay. So I have this molecule, I can see this anhydride here, PCl5, okay, and then we have lithium aluminum hydride. So let's start by adding PCl5. So the bond will break and we get acyl chloride. So in the first step, I have, after adding PCl5 in this is A. Now lithium aluminum hydride, the reduction will happen, this becomes CH2OH. This is also reduction happens, CH2OH. This is my B, guys. This will be B. Now PCC, okay, oxidation. You all know alcohol will become aldehyde by using PCC as an oxidizing agent, CHO. Now the last is OH. So you have two CH and you have this alkali medium OH negative. This was C, this was your C, guys. Now the last alkaline medium CHO without alpha hydrogens. What is it? Canizaro. So Canizaro will happen right in the last step and you have got a disproportionation reaction. One will become alcohol, another will become acid. Got it? Yes. Done, guys. Or let me be very clear. Got it? So the product D is, what is D? What is the product D, guys? What is the product D? Here the product D is, this should be benzene, guys. This should be benzene. The C option should be benzene. The C should be benzene. COH is a stronger acid, that will lose. Perfecto. Here has to be benzene. Got it? Yes. So the answer is C. Okay. Now the next question. Make it 13th question. Which of the following is not correct? Which of the following is not correct? Let's check it out. So we have this chromium complex where the chromium is there and we have 6 ligand octahedral complex of chromium. Both have D2sp3 hybridization. Of course, we can see the strong field ligands here. Cyanide is there, you can see, guys, right? And ammonia is there. The strong field ligands, they do the pairing. Yes, guys, the pairing will happen. So when the pairing happens, inner D complexes are being formed. When the pairing happens, inner D complexes are being formed. So D2sp3 hybridization both. Magnetic moment of this complex, okay, sodium nitroprusside is 4.89 Bohr magneton. This is very important, a special case. I am sure you must have done it in this complex. We have NO in +1 oxidation state and Rn is also in +1. So Fe in +1 means very, very important. We definitely would focus on this, right? Fe +1. Now this electron goes here, does the pairing, and we get, so if this goes here, we have 3 unpaired electrons. special case, NO is in +1 oxidation state. 3 unpaired electron means the magnetic moment should be 3 point something, right? So if the magnetic moment is 4 point something, that is not correct. 3 unpaired electrons are there, guys. So very important, just take a note, which is not correct, it is incorrect. Next, both are like DsP2, both are square planar complexes. The platinum complex, you can calculate DsP2 both. The strong field ligand, you can see, right? They all are having strong field ligand, so there is pairing happens, right? So DsP2 inner orbital complexes. It is difficult to substitute chelating ligand compared to similar monodentate ligand because chelating ligand gives extra stability, right, to the complex ion. So it is very difficult to replace or substitute a chelating ligand because of that chelating ligand chelation, the stability of the complex was enhanced, right? So indeed, the answer to this question is, of course, right, B. Let's move ahead. Which of the following statements are correct? Let's check out which of the following statements are correct. Both melting and boiling point of H2O are higher than H2TE. Yes, because of indeed hydrogen bonding in H2O. This is true. In N2O5 and N2O4, all NO bond lengths are equivalent. Of course not. Those who know the structure of N2O4 and N2O5, they must be able to show the structure also, right? There's a partial double bond like character because of resonance and all. And in both crystalline sodium bicarbonate and potassium bicarbonate, the bicarbonate ion only form dimeric anion through hydrogen bond. In potassium bicarbonate, is very much written in the your JDE, that Indian edition for JEE Advanced. So your potassium bicarbonate, that forms a dimer, but it exists as a polymer. Many bicarbonates, they are just joined together and will give a long chain like structure. So this is also not true, right? Amongst B2, C2, N2 negative and O2, N2 negative and O2 on losing electron becomes more thermodynamically stable. So let's check it out, the bond order of all. So I have N2 negative. When it loses electron, it becomes N2. N2 negative, the bond order is 2.5. In N2, the bond order is 3. And O2, bond order is 2. And O2 negative, it becomes 2. The O2 positive, it becomes 2.5. Yes. So the bond order increases, bond strength increases, so they become more stable, of course. So which are correct? First is correct and this is correct. These are wrong. So of course I will mark our answer as D, donkey. 1 and 4 are correct. Let me show the structure also. So guys, this is N2O4. You can see 5 valence electrons on nitrogen, right? 5 valence electrons on nitrogen. So you can put a positive charge on nitrogen, negative charge on oxygen and do the resonance. So here you can see the structure of N2O5. So there is a single bond, there is this double bond. So of course the bond lengths are not same in both, right? In N2O5, it is not the same, guys. You can see there is a single bond also, there is a partial double bond also. And in bicarbonate, this is how the bicarbonate ions are linked in sodium bicarbonate. And dimeric form in potassium bicarbonate, 2 bicarbonate ions join together and exist as the dimer, right, guys? So please, in N2O5, the bond lengths are not equal. In N2O4, it is. Now the next question, okay. So you have a molecule, organic molecule with a chiral carbon. I'm sure you all can see. If you can't see, by looking at this R configuration, you can make it out that there is a chiral carbon here. Now this chiral carbon is here. Of course, free radical halogenation. Hydrogen is replaced by chlorine. Different products will get. Okay, what are the products that we can get here is, let me, so PH, CH, CH. This hydrogen is replaced by chlorine. This is the one product, right? This is first product, say. Now the second product I will make PH. I will replace this H, CH2, CH3. This is the second product. This chiral carbon hydrogen is being replaced by chlorine. Now the third product. Let me make the third product. So we have PH, we have CH, we have CH3. Now on this we have chlorine and here we have CH3. This hydrogen is replaced by Cl. And let me have the fourth product also. PH, CH, CH3 and CH2. And these are the different products that we can get. Yes. So we are only making the monochlorination product, as it is not written that Cl2 is in excess. So we are just making monochlorinated product. Now, total number of products. Let me first see. This is my chiral carbon. This is also my chiral carbon. 1, 2. This is chiral and this also has become chiral. 2 chiral carbon it has, right? And the configuration is fixed. I can see the configuration is fixed. Right, guys? Please check. R is the configuration. The configuration given is R. Yes? Perfecto? Done? So this configuration is fixed. This is R, one product. You can see this is the another product, right? On which the substitution happens at chiral carbon. The substitution happens at chiral carbon. This. So this is D or L both. Because free radical substitution happens at this carbon. This is only one isomer because the configuration of this is fixed. Now this, we have two. Configuration is fixed. Say this is D, this can be D, this is fixed, that is D, this can be L. Right? Yes? And this is the one. So let me count the total products that we get. 1, 2, 3, 4, 5, 6. 6 total products. Right? And how many fractions in fractional distillation? The one which have different boiling points, right? We will not count the enantiomers, but definitely will count the diastereomers, if any. Right? So the total isomers 1, 2, DL, same, right? Because they are enantiomer. 1, 2, and here 3, 4, they are diastereomer. DD and DL, they are diastereomers. So 1, 2, 3, 4, and 5. So 5 is the total fractions that we get in fractional distillation, right? So answer I will mark as total 6 product and 5 fractions in the fractional distillation. So guys, I hope you get your answer as A for apple, right? Interesting question based on a very simple common reaction, free radical halogenation. Okay. I have alkene and a very famous reaction. I can see the reagent that we are using here, B2H6 and THF, H2O2. So hydroboration oxidation reaction is happening that will result into the formation of alcohols from alkene via syn addition. So hydroboration oxidation, what will be the product? So we have this alkene, it will form alcohol. So syn addition will happen. CH3, I have H here, I have OH here, right? This is the product after this hydroboration oxidation reaction. Now this tosyl chloride, so this will be replaced by OTS. So here I have OTS, right? OTS, a good leaving group. And then tertiary butoxide. Tertiary butoxide is a bulky base. Elimination will be favored, right? Yes, elimination will be favored. So let me here we have 2 hydrogens. Yep, here we have 2 hydrogens. Now the last step is elimination via bulky base. Anti-elimination will happen. Yes, just take care guys, anti-elimination will happen. Anti-elimination, anti-elimination. So OTS from this side and the opposite side hydrogen will go. This hydrogen is on the same side. So this hydrogen will go, right? Because from the opposite side, anti. So the final product we have is, there is a double bond and here is the CH3. Now the final product Y is this. A positional isomer of X. Of course, this is X, this is Y. The position of double bond is varying. So, of course, the answer I will mark is A. The position of double bond has changed. Yes, or you can say, rather I will say the position of CH3 has changed. Yes, so it is a position isomer of X. Identical chain isomer, no. The answer will be A. Please see, first is hydroboration oxidation followed by the substitution by OTS and then elimination, anti-elimination by bulky base tertiary butoxide. Got it, guys? So we'll mark its answer as A. Now the next question. Okay, so this is an interesting question. Most of you might have, left this question in the paper. But if you have left this question in the paper, do not worry. Good call that you have taken, because you might get wrong somewhere, right? So there is this carbonyl compound, you put H positive, and then this acetone is there, then minus H positive plus H. You have to devise a mechanism actually, and then water is being removed, then repeat the sequence, and then ammonia, and then the final product. And they are asking you what is A, what is B, what is C, D, E, F. You have to check, right? So let me show you the mechanism itself. So you know, first step, there is a carbonyl and H positive, right? So H positive. So this is a carbonyl and you add H positive. So of course your H positive will attack on the lone pair of oxygen. So we have H positive. The lone pair of oxygen will get attacked. So we get this. Keto-enol, you can say. Enol. Now you add this. So what will happen, right? Plus H positive minus H positive. So H positive can attack here, resulting in the formation of carbocation. This double bond gets, and it will attack on the acidic hydrogen here. So this is the acidic hydrogen. There is a negative charge, there is a positive charge. They just attack and make this. This is the B compound. Right? After that, just remove water and make a double bond. Elimination, dehydration of alcohol, that will give you this alkene. Right? So this is your C. Again, H positive, that will attack on the lone pair of oxygen, and keto will get converted to enol. Again, the same thing will happen. Similar kind of process, you will get this. This is your D. Then ammonia. You have this ammonia, right? That will attack. Ammonia will attack on this carbon, and NH2 is being substituted here. And then further, you will get this in the last step. Repeat the sequence, because you have repeated the sequence, then ammonia, and then from E you get the F. So this ammonia, and there is a ring formation, right? So this, I will say, you might get wrong somewhere. You might not be able to deduce the actual mechanism happening here. So if you have left this question, do not worry. There are certain questions that you should not spend a lot of time on, because that will decrease the efficiency in the paper, right? So if you're not getting it, just leave it right away rather than spending 5-7 minutes and leaving it. So you are just supposed to figure out which is not the correct product in the above sequence. That is, B is this. This is not B. B is in fact this. When the H positive and H negative goes, like positive negative forms a bond. Okay. Now the question number 18th. Okay. So you have this, right? You have ester and an alpha carbon. You have halogen. So what will happen? PPH3. So your Br will be replaced by PPH3. I hope by looking at this, you might get the idea which reaction is might be going to happen here. PPH3 is there, right? So this is the first step. Br is being replaced by your PPH3. Got it, guys? This is the first step. Then you add C2H5O negative, that is the base. Then you add a base, right? What will base do? Base will abstract the acidic hydrogen. So these are the acidic hydrogens that we have. So your base will abstract the acidic hydrogen, right? So here there's a double bond, and this goes here, you can say, and OET. This is the another product after addition of a base that can abstract the acidic hydrogen and make a double bond there, right? This one. H positive goes here, negative charge, there's a bond. Okay, now on this you add CH3CHO. Now here is the story. What reaction? Ild, phosphorus ild, and this CH3CHO aldehyde. Wittig reaction. Common, famous name reaction. I don't know how many of you have done it. Yes, Wittig reaction will happen. Wittig reaction will happen, and what will happen? This goes from here and this join here, right? That is the Wittig reaction. So guys, what are the products that is being formed here? Wittig reaction, that is the main point here, right? That is the main point. What is the product that is being formed here? So you can say this will join here, right? So this part OAT, and there's this double bond, and you join this CH3 from here. Got it, guys? So what is the product? Joining these two, A will be the product. Wittig reaction, guys. Please, those who don't know what the Wittig reaction is, make sure after giving this test, you should be looking at the Wittig reaction, and keep in mind, phosphorus ild, we use Wittig reaction. right? This is, so we have this acetaldehyde, we have this here, they will break from here and this will join here in place of O, right? You can see the entire process. Now the next question, okay, so we have this organic molecule where I can see 2 bromine and we are using 2 molar equivalents of this. You can clearly see there is a substitution of a Br. So let me do the substitution. So I have this ring and your Br is replaced by this. This is it. Now barium oxide, what it will do, guys? Yes, yes guys, so this SN2 happens here, yes, and then CH3I, this substitution happens, CH3I, again 2 equivalent, 1 CH3, quaternary ammonium salt, E negative is here, will happen. Now Ag2O H2O, guys, quaternary ammonium salt you get, right? So I negative will be replaced by OH negative and nothing else. Now heating the quaternary ammonium salt, remember what will happen? This will go out and the product that you will get is Hofmann elimination, the less substituted alkene. So after the last step, quaternary ammonium salt heating, they will just go out, right? Yes, Hofmann elimination will happen, right? And you'll get double bond here, double bond here. So finally the product that you will get is benzene. Benzene is the product that you are finally getting in this reaction, guys. Along with, of course, these molecules, they will eliminate, right? Quaternary ammonium salt, important reaction. Quaternary ammonium salt on heating, they loses that and forms the Hofmann alkene wherever it can form. The rest all are CH3, so alkene cannot be formed. It can only form here. Elimination will happen, right? So important reaction again, guys. The product is benzene, beautiful product. See, you can see it. Okay, next question. The last objective question I can see is from qualitative analysis. From solution of containing copper 2 positive, zinc 2 positive ion, copper 2 positive ion can be selectively precipitated using sodium sulfide. Okay, we have copper ion and zinc ion. Is it true or false? So guys, copper ion, zinc ion, if we add sodium sulfide, it gives a lot of sulfide ions, and the KSP of both copper sulfide and zinc sulfide can be reached, and the both will get precipitate out. So this is not the correct statement, because we are giving a lot of sulfide ion concentration that is sufficient to reach the KSP of both copper sulfide and zinc sulfide. So this is a false statement, guys. Amongst calcium, aluminium, bismuth and magnesium, the ammonium chloride and aqueous ammonia will precipitate only aluminium ion as it is hydroxide. So guys, I will say group 3 reagents basically we are using, and in group 3 we have aluminium hydroxide, ferric hydroxide and chromium hydroxide, right? Which will get precipitated as hydroxide. But these are the ions. We have calcium, aluminium, bismuth, magnesium. Indeed, aluminium will get precipitated out. Calcium, magnesium belong to another group. Bismuth, because this is sufficient. Their case, the hydroxide of bismuth is also not having very high value of KSP. So the bismuth hydroxide will also get precipitated along with aluminium hydroxide. So not just aluminium, right? Bismuth, because of its low KSP for hydroxide, it will also get precipitated out. Again, false. Sodium chloride on reaction concentrated H2SO4 in the presence of MnO2 liberate a greenish yellow gas. Chlorine is liberated, which is of course greenish yellow gas. This is true. The formation of brown precipitates on reaction with alkaline. Oh, this is Nessler's reagent. I hope you know. Nessler reagent is used for the detection of ammonium ion. If ammonium ion is there, ammonium ion are present in the salt, you add Nessler reagent, they will form a brown precipitates of the complex. Very important. So this is also true. So false, false, true, true. So answer we will mark here is our C. Right? So you can say this is the Nessler reagent reaction. This is the complex that is being formed. Brown color precipitates. Right? So please check it out. Bismuth hydroxide, aluminium hydroxide, both will form precipitates. Now the numeric value equation. Number of the following compounds that cannot be synthesized in good yield by Williamson synthesis. So Williamson synthesis, we synthesize ether by using alkyl halide and of course sodium alkoxide because it is a substitution reaction, right? So the primary, as via going through SN2 mechanism is happening, X is being replaced by OR negative, right? Alkyl halide, X negative is being replaced by OR negative by SN2 mechanism. So that means those alkyl halides which are less crowded, or we can say primary alkyl halides, they give the best results for Williamson synthesis, right? Got it? So SN2 mechanism, Williamson synthesis. Let me write the journal reaction. So this is R-X alkyl halide, O negative, R Na positive, you get ether. Right? Along with NX, of course. So it should be less hindered, primary, because the reaction, the substitution is happening. This is being substituted by this by SN2 mechanism. So let's see where we can get the best results, which cannot be synthesized. This can be synthesized. I can see the primary halide. We can use phenoxide. We can use phenoxide ion and methyl halide, right? That can also be used. See, phenoxide is used, but this alkyl halide, if this is used as alkyl halides, backside attack is hindered because of this bridged carbons and this type of structure. So we'll cross this. Okay. So to have this, I should have aryl halide, right? And also has phenoxide ion. Phenoxide ion is fine, but aryl halide will not give substitution, right? And this phenoxide ion is fine. 3 degree will not give SN2 because backside attack is hindered. Again, this can give, no issues with it. This cannot. One is 3 degree. This can also not form alkyl halide. This is, right? So how many of them cannot form Williamson synthesis in which there is a backside attack? So let us count 1, 2, 3, 4, right? So we'll mark our answer as 4. SN2 mechanism, backside attack has to be feasible. Your alkyl halide should be primary, can be secondary, but it should not be sterically hindered, right? So the answer for this question indeed is 4. Perfecto. Let's move on to the next question. What should be the minimum pressure applied on 0.1 molar glucose solution filled in a semi-permeable membrane so as to filter away 750 ml osmosis of water, leaving 250 ml. Okay. So guys, simple. Osmotic pressure pi is equal to CRT. They are asking you this. R, you know, temperature, you know, but make sure this is the molarity of 1 liter solution. From that 1 liter, 750 ml is out. You just have 250 ml. So the molarity will increase, volume decreases, water 750 ml goes out. That means now the molarity after the loss of, for 1 liter solution, we have 0.1 moles. Now we have 0.1 moles in 250 ml. Right? So there is a change in the concentration because there is a loss of solvent. The volume of solution decreases. Right? So suppose initially M1 V1 is equal to M2 V2. Initial molarity 0.1, volume was 1000. Now the molarity volume is 250. Got it? So 0.4 it will be. So just put the C is equal to 0.4. Rest, very simple direct application, and I'm sure you can do this. Yes, directly. So of course 9.6 is the answer. Just the simple formula, pi is equal to CRT, the osmotic pressure colligative property. Now the next question, guys. Identify the total number of compound gives immediate turbidity with Lucas reagent. Immediate turbidity, Lucas reagent, which forms a stable carbocation. The alcohol which forms a stable carbocation will give the immediate turbidity with Lucas reagent. Let's check out what carbocations are being formed. So OH will go here, and this is the carbocation. Not much. Oh, this is very stable because of dancing resonance. Yes, the most stable in fact. 3-membered ring, on the adjacent carbon there is a positive charge. The dancing resonance, the bent orbital resonance, the most stable carbocation. Very right. Now this will go, we have a positive charge here. OH will go positive charge. Aromatic, this is also stable carbocation. OH will go positive charge here. 4 pi electrons, the ring, this is not aromatic, rather it becomes anti-aromatic, so it is not stable. This is also stable. 3 degree carbocation is being found. OH will go positive charges here. This OH will go, this is the positive charge, not much stability. This OH will go again. benzene ring is there, resonance is there, OH will go, positive charge will come here, which can do resonance with the lone pair. So all those alcohols which forms a stable carbocation after the loss of OH negative, they will give the instant turbidity in Lucas test. So let's see, this is 1, 2, now this is unstable, highly unstable, 3, 4 and 5. So 5, instant turbidity, which is very stable carbocation. So we'll mark our answer as 5. So dancing resonance, aromatic, 3-degree carbocation. This is also resonance. Here is also resonance, resonance stabilized carbocations. So the answer indeed is 5 here, guys. Right? 5 is the answer. So they all will give instant turbidity. Now the total number of boron atoms in anionic part of borax. So borax, this is the cationic part. Na positive, this is the anionic part, which forms sigma coordinate bond is X, and the total number of boron atom which can form p pi coordinate bond is Y. Then calculate X minus Y. So it is basically a question based on the, you can say, what you can say, the structure of borax, right? The structure of this ion borax. I hope I am, I want every one of you to know the structure of borax. Very simple, very symmetrical structure, no difficult. And if you know the structure, now you can easily crack this question, guys. This is the structure of that negative part, B4O5OH. So boron, 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 this boron and this boron, they are sp3 hybridized, right? This boron, they are kind of sp2 hybridized. Yes. So here is a pi bond formation because boron is electron deficient, right? And they are forming this boron negative, they are forming sigma coordinate bond. So we have 2 sigma coordinate bond, we have 2 pi kind of coordinate bond, p pi. Yes, p pi oxygen and boron. So X is also 2, Y is also 2, so X minus Y is 0. If you know the structure of borax, which is very important, I'm sure you all know, right? Very symmetrical, easy to remember also. Put 4 borons, put oxygen in between. There are 4 OH, put 4 OH with each boron and join 2 boron with the oxygen bridge. You get the structure? Yes. So the answer indeed is 0. Now the next question, find the number of non-redox reaction. So non-redox reaction means in which the oxidation state is not changing. If there is a change in oxidation state of any species, that means this is a loss or gain of electron, that is a redox reaction. So all these reactions are given. Mostly the reactions are from xenon or nitrogen compound, which is indeed very important from P block, especially xenon fluorides, the reaction very important. Let me show you the products and then let's check out which will form. So guys, you can see here the products. When XeF2 reacts with water, hydrolysis, you can see here guys, when it undergoes hydrolysis from xenon, let me write the oxidation state. So these reactions pretty important, you should remember, you should know the products guys. So xenon fluoride, xenon from +2 is going to 0. This is a redox reaction, redox. Oxidation state is changing, +2 to 0. N2O5, right? So nitrogen is in +5 oxidation state, this is the product HNO3. That is also +5 oxidation state, non-redox. The oxidation state remains same. Here, if we see +3 oxidation state of nitrogen remains +3. Again, no change in the oxidation state of nitrogen. Again, non-redox. Here, +6 oxidation state of xenon remains +6. XeO3 is the product. Plus HF, right? So the product in this reaction is when XeF6 undergoes hydrolysis reaction with water, XeO3 is being formed. In XeO3 also the oxidation state of xenon is this. So again here also no redox. XeF4 on hydrolysis, XeF4 xenon is in +4 oxidation state, gives xenon here, and this is kind of disproportionation reaction. Xenon from +4 is becoming 0, right? And xenon from +4 is becoming +6. So it is undergoing reduction as well as oxidation. This is a disproportionation reaction. So of course a redox reaction it is, right? So they are asking how many of them are non-redox reactions. So first is redox and the last is redox, and these 3 are non-redox reaction in which there is no change in the oxidation state of xenon or nitrogen, right? So guys, the answer will mark here is 3. So if you know the product, then only you can answer it, right? I hope everyone is aware of what is oxidation, what is reduction. But to answer this question, you are supposed to know the product of hydrolysis of xenon fluorides or the nitrogen oxides, right? The hydrolysis reactions are given. Hydrolysis reactions, they are very important, guys. Frequently, the questions have been asked in JEE from hydrolysis. So that's all for today, guys. I hope you did this paper really well, and I hope you are analyzing your paper after doing it so that you will not repeat the mistake next time, right? So keep learning, keep growing, guys. All the best.
Hello everyone, I am Surendra Jain, Master Teacher of Maths in Vedantu. I am discussing Eklavya JEE Test 2, which was conducted recently. This is question number 1, where we are given one alpha as a complex number and then one series of alpha square, alpha power 6, and we have to find a quadratic. So please see how this question we will do. Here alpha is having mod equal to 1 and argument is minus pi by 6. So I can write this as e power minus iota pi by 6. Okay. My first series, that is A, is actually equal to 1 plus alpha square plus alpha power 4 and so on till alpha power 198. Okay. Now alpha square, if I write, it is actually equal to e power minus iota pi by 3. And if you look at this alpha square, e power minus iota pi by 3 on Argand diagram, this will be at 60 degree with x-axis in clockwise sense, so that is alpha square, which is actually directly opposite to the imaginary complex cube root of unity, that is omega, that comes in the second quadrant. Actually the angle here is 120 for omega, so this alpha square is actually equal to minus omega. Okay, now once we know that is minus omega, I think to find the value of A will become easier. Otherwise also you can do, because this is just the GP of 100 terms, because starting with 0 going up to 99, so total 100 terms whose first term is 1 and common ratio is alpha square, which is actually minus omega. So I can write it as minus omega raised to the power 100 minus 1 divided by minus omega minus 1. Okay, that is the sum of 100 terms of a GP. Okay, here omega power 100 will be just omega minus 1 upon, in the denominator it is omega plus 1 with minus sign outside. Okay, 1 plus omega we can write it as minus omega square, so it will be actually minus 1 will go, will not be there, so we will be having omega minus 1 upon omega square. So we can write it as omega upon omega square as 1 upon omega, which is also actually equal to omega square minus omega. Omega can be written as omega power 4, so omega power 4 upon omega square is omega square, and likewise 1 is omega cube, so omega cube upon omega square is omega. Now if we put the values of omega square, which is actually minus 1 minus root 3 iota by 2, and for omega it is minus 1 plus root 3 iota by 2, so this minus 1 will get cancelled and we will be having here, I think, only minus root 3 iota, yeah, minus root 3 iota. Okay, and similarly we have to find the B. In fact we need A square, so A square here would be the square of this thing, which is actually minus 3. Now if we try to find B, actually here we are having alpha power 6k, so alpha power 6k means it is actually 1 plus alpha power 6 plus alpha power 12 and so on, and here we will be having 101 terms. It is going up to alpha power I think 600, yeah, 600. So you can see this one will be 1 alpha power 6, which is actually cube of this minus omega, so it will be minus 1, then it will be plus 1, then it will be minus 1 and so on. So they are all alternate plus 1 minus 1 and their total number of 101 terms. So I think if I keep first term outside, all remaining terms should cancel each other, so the value of B will be equal to 1. So here we have got A square to be equal to minus 3 and B to be equal to minus 1. So from this we can find the quadratic, because sum of roots will be equal to minus 3 plus 1, so minus 2, and product of root will be equal to minus 3. So from this we get the equation, we get the quadratic equation to be x square plus 2x minus 3. So answer for this question should be B. Okay, so I think the main thing about this question was to solve for A square, because even B is easier. Now question number 2. Now this question we are given system of linear equation for lambda belongs to R, the set of real number is. Okay, now for this question, when I created this question, actually this paper was created by me only, so how I made this question I will tell you. The process was that if you take lambda common, it can be written as x minus 1 here plus y plus 2 times z minus 1 equal to 0. And the second equation, x minus 1 plus lambda y plus 3 common z minus 1 equal to 0. And the last one we can write it as minus 2 common x minus 1 here. Okay, because this minus 2 will go that side, so it will become plus 2, and then plus y plus lambda common z minus 1. So what you can see that if we take x minus 1, y and z minus 1 as new variables, this is actually homogeneous equation, because on the right hand side we are having 0 0 0, which means x equal to 1, y equal to 0 and z is equal to 1 is always going to be the solution. There is no chance that you are having no solution wala case here. So no solution, I think this option is wrong. Now either we will be having exactly one solution or we will be having infinitely many solutions. Now for that we need to have the delta or determinant value of the coefficients, which is actually here lambda 1, 2, 1, lambda 3 and minus 2, 1 and lambda. Now if it is equal to 0, it will have infinite solution. If it is not equal to 0, it will have unique solution. Now we can open it and we will get first row. If I open, so lambda square minus 3, then minus 1 into, it will be lambda plus 6, lambda plus 6 and plus 2 into, it will be 1 plus 2 lambda, 1 plus 2 lambda. So this becomes equal to, I think, minus 3 lambda. I think lambda terms gets cancelled. So we are getting lambda cube minus the constant term is just 4. Okay, so this will be equal to 0 only for lambda equal to 4 power 1 upon 3. So it will have infinite solution for exactly one value of lambda, whereas the option says exactly one solution for exactly one value of lambda is wrong, because for that one value of lambda it will have infinite solution, other than that it will have unique solution. So exactly one solution is for infinite values of lambda, so this is also wrong. And then exactly one solution for more than one value of lambda seems right. Exactly one solution for more than one value of lambda seems right. So C is the answer. Okay, so I think we can go ahead. Let us see what is the answer here. Yes, C. Now if you do not, if this idea doesn't click that we can write like this, then I think you have to find d equal to 0, then dx dy dz. From there you will be able to see that for how many values of lambda we are getting no solution. So then this will become a bit lengthier, but it's a standard problem. You can solve that way also. Okay. So moving to the next question, that is question number 3. Here we are given that line cut the circle in 2 points, then exhaustive set of values of lambda is. I think one very standard problem, that there is a circle here, then one line, we want this to cut at 2 points. That means from the center, which is actually 2, 4 here, center is 2, 4 here. If we drop perpendicular to this line, whose equation is 3x minus 4y minus lambda equal to 0, okay, then the distance d has to be lesser than the radius, and the radius of the circle is under root of 2 square plus 4 square plus 16. That means it will be, I think, 6. Yeah, it will be 6. So my perpendicular distance from 2, 4 to this line will be 6 minus 16 minus lambda. 6 minus 16 minus lambda divided by, I think, 5, and mod of this should be less than 6, not even equal to 6. So we have to solve it. I think it becomes inside, this is actually minus 10 minus lambda less than 30. We can write it as lambda plus 10 also. Inside the mod is less than 30. So that means lambda plus 10 will be less than 30 and greater than minus 30. So we get lambda to be between 20 and minus 40. Minus 40 to 20. So answer for this question is C. Okay. Moving to the next question, that is question number 4. Let the shortest distance between the lines L and L1 be 3 root 6. Then plane parallel to both L and L1 and equidistant from both the lines. Okay. I'll tell you slightly different method for this question. Please understand. Whenever we are having two skew lines, maybe something like this, okay, and we are looking for shortest distance between them, then this shortest distance is always along that line which is perpendicular to both the lines. Okay, you can imagine two lines, something like this. This pen is one line, this finger is one line. Okay, now the shortest distance between them will be along that line that is perpendicular to both. You can imagine, actually, yeah, there will be one point here, and if you join them, so that will be the shortest distance. Now to find the shortest distance, what we can think of, we can think of two planes, both of them passing through this line, and which are actually having this line which is perpendicular to both of them as the normal. I'll tell you what I'm saying. We can assume two planes like this. One of the line is lying in this plane and other line is lying in this plane, and the line of shortest distance which is perpendicular to both the line is actually normal to both the planes, which means these two planes will be parallel to each other, and in that case the perpendicular distance between these two planes will actually be the shortest distance between the straight lines. Why I am doing in this way? Because we are actually looking for another plane like this only, which is parallel to both L1 and L2, then plane parallel to both L1 and L2 and equidistant from both the lines. You can see both the planes are such that it is containing first line L here, and it is also parallel to line L1 here. Similarly, other plane is also like this only. It is containing line L1 here and it is parallel to line L. So these two planes will be parallel to each other. These two planes will have normal which is actually perpendicular to both the lines L and L and L1 actually. And the distance between these two planes will give you the shorter distance 3√6. And from there we can find other plane also. So my first thing is that normal of this line that is perpendicular to both L and L1 can be found using the cross product of the direction ratios of these two lines, which is actually -2, 0 and 1. And for this it is 1, 1 and -1. You can see it is 4 minus that, so -1 will be written like this, I, J, K, first row. So for I it will be 0, -1, okay, and for J it will be 2, -1, 1, but there is one extra minus sign also, and then K it will be -2, yeah, just -2. So we are getting this as direction ratios of the line that is perpendicular to both L and L1. It can also be written as 1, 1, 2. Okay, you can check this direction ratio is such that it is perpendicular to both the lines. First line is having direction ratios -2, 0, 1, so -2 plus 2, 0, and for second line it is 1 plus 1, 2, -2, yeah, that's correct. Okay, so that is the direction ratio of this line which is actually perpendicular to both the lines. And as I said, if we take two planes, one containing L and other containing L1, and having direction ratios and having normal whose direction ratios as 1, 1, 2, then these two planes will be parallel and distance between these two parallel planes will be equal to this 3√6. Okay, so my first plane will be x plus y plus 2z. Okay, and this plane has to have a point lying in this plane, and the point is actually 5, lambda, minus lambda. So that is the point lying on the line. So this point should be lying on the plane also. So if I put this point here, so I think I will be getting 5 plus lambda minus 2 lambda. So I think 5 minus lambda. That is the equation of first plane. Likewise, for the second plane, it will be x plus y plus 2z. And in this case, the point lying in this line is -1, 1, 4. So if we put it here, 1 minus 1, 0, and it will be equal to 8 here. Now, distance between these two planes, you can find out by taking the difference of the constant terms. So it will be 8 minus 5, that is 3, plus lambda upon under root of 1 plus 1, 2, 2 plus 4, 6. So that is equal to 3√6. Okay, this will be actually mod here. So from there we get 3 plus mod 3 plus lambda equal to, I think, either plus 18 or minus 18. But because we are given lambda to be positive, so we will consider only plus sign here. So lambda is equal to 15. Okay, so if it is 15, then you can see this will be equal to -10. This will be equal to -10. Okay, now we are looking for a plane that is parallel to both L and L1 and equidistant from both the lines. It is a plane actually that is mid parallel of these two planes. If it is mid parallel, so it will be having x, y and z terms similar to what we are having for these two planes, and the constant term will be the mean value of these two. It will be just -2 on the other side, x plus y plus 2z on the left hand side. On the right hand side, it will be -10 plus 8. So -2 divided by 2, so -1. So that will be my final answer. Why mean we have taken? Now you can see the distance of this plane with the first one here and the second one here will be same. So that's why it is actually mid parallel plane. That is what we are looking for. X plus y plus 2z is equal to -1. Okay, you could have done it other way also, which I think is done here. Yeah, where you take the shortest distance formula as vector taken by 2 points on the lines, then direction ratios of the lines divided by cross product of direction ratios of 2 lines. From there also you can find the values of lambda. I think we are getting same value of lambda as 15 or -21, which we have rejected, and then you can find the equation of plane that you have to again do by the cross product only. Okay, so moving to the next question, that is question number 5. We are given here A and B are two unit vectors such that A cap plus B cap plus 3 times A cross B is equal to 4 root 2 upon 3. If theta belongs to 0 comma pi by 2 is the angle between A and B, then theta we have to find. See, if theta is the angle between the vectors, then A cross B will be a vector n cap, that is a unit vector, along a direction which is perpendicular to both A and B into sine theta. Okay, because A and B both are unit vectors, so mod of A is 1, mod of B is 1 into sine theta into n cap. Okay, so this is A cross B here is, and this n cap will be perpendicular to both A and B. Now we are given the magnitude of this vector A cap plus B cap plus n cap, actually 3 times n cap into sine theta equal to 4 under root 2 by 3. If I do the squaring both sides, okay, my left hand side will be the dot product of this vector with itself, which means it will be A cap dot A cap plus B cap dot B cap plus 3n cap sine theta dot with 3n cap sine theta, okay, plus 2A dot B plus 2 times A dot 3n cap sine theta, which will be 0 because A cap n cap are perpendicular. Likewise, B cap dot product with n cap will also be 0. So that is all what we will have on the left hand side, and that is equal to 16 into 2, 32 upon 3. So 1 plus 1, 2, okay, and that is 2 here, plus here we will be getting 3 into 3, 9, 9 sine square theta. 3 into 3, 9 sine square theta plus 2A dot B means it will be 2 cos theta, because A and B are unit vectors. So A dot B is 1 into cos theta is equal to 32 upon 3. Okay, now we can convert sine into cos. So it will be, I think 9, let me write completely, 2 plus 9 into 1 minus cos square theta plus 2 cos theta is equal to 32 upon 3. So 9 cos square, if I take that side, I will write c square in shortcut, and minus 2 cos, okay, and then what is the constant term? Here it was 7, it was 11. 11 if goes that side, so it will be, I think, minus 1 by 3 equal to 0. Yeah, that's right. So 27 cos square minus 6 cos minus 1 equal to 0. If we factorize it, I think it will be minus 9 plus 3, splitting the middle term. So minus 9 plus 3 means it will be 3 cos minus 1 as one factor, and 9 cos plus 1 as the another factor. Let us see. 9 into 3, 27 cos square, 3 minus 9 minus 6. Yeah, that's right. So cos will be either 1 by 3 or minus 1 by 9, but I think we want this to be acute angle. So the answer can be cos theta is equal to 1 by 3. So cos inverse 1 by 3 will be the answer. All other answers are, I think, not matching. So B is the answer of this question. Okay. Now here we are given a question in which A is a 2 into 2 matrix ABCD as entries, and they are randomly chosen from the set 0, 1. Then the probability that A inverse does not exist. A inverse does not exist means that value of determinant, which is AD minus BC, should be equal to 0. Okay. Now AD minus BC, because A, B, C, D all are coming from the set 0, 1. So A into D product can be either 0 or 1. Likewise, BC also, the product BC or AD can be either 0 or 1. Now, if we want this to be 0, this means I need to have AD equal to BC equal to 1. That's the one scenario. And that is possible only if when A equal to D equal to B equal to C equal to 1. Because if you choose any one of them as 0, then their product cannot be 1. So that is just one scenario when all A, B, C, D are 1, 1, 1, 1. Okay. Or other scenario can be when AD and BC, they are equal to 0, 0. Now, zero product can be if any one of them is 0 or both of them are 0. So, if one of them are 0 means A is 0, D is 1, or A is 1, D is 0, or both A equal to 0 is equal to D. So, you can see for AD to be equal to 0, there are 3 scenarios. And there will be 3 scenarios for BC to be 0 also. BC can be 0 again in 3 ways. So, total ways will be 3 into 3, 9 here. And 1 case here, 1, 9 case here. So, total there are 10 ways in which this determinant can be equal to 0. Whereas ABCD, if we choose independently, so every one can be chosen in 2 ways. So, 2 into 2 into 2 into 2, 2 power 4, that is 16. So, answer will be 5 upon 8. So, answer for this will be 5 upon 8. So, B will be the answer of this question. Okay. Question number 7. Here we are given fx equal to a1 cos inverse x plus a2 cos inverse x whole cube plus a3 cot inverse x, where f is from -1, 1, which is basically the domain of cos inverse function. 2R set of real number is a function, and a1, a2, a3 all are positive integers. Now please see, this cos inverse x function is a decreasing function. Okay, and if cos inverse x is decreasing function, I think cos inverse x whole cube will also be decreasing function only. You can check by doing differentiation. And cot inverse x is also decreasing function. Its differentiation is -1 upon root over 1 minus x square. Its differentiation would be 3 into cos inverse x whole square into -1 upon root over 1 minus x square. And for this, it will be -1 upon 1 plus x square. Okay, so all 3 are having negative derivatives to decreasing function, and they all are continuous function for this domain -1, 1. Even this cot inverse function, cot inverse -1 is, wait, for cot inverse function, if I draw the graph, cot inverse -1 is 3 pi by 4. Cot inverse -1 is 3 pi by 4, and cot inverse 0 is pi by 2. Yeah. Why I'm getting confused? Something like this. It will be at -1, it will be 3 pi by 4. Okay, at 0, it will be pi by 2, and at 1, it will be pi by 4. Yeah, so it's a continuous function, decreasing function. So all 3 are continuous decreasing function. That means it has to be a decreasing function. That means it has to be 1, 1 function. But let us talk about onto function. Please see, because cos inverse x function is having a limited range. It is having from 0 to pi. This will also be 0 to pi cube, and this will be for -1 to 1 will have range values from pi by 4 to 3 pi by 4 only. So if I put all values of x from -1, 1 close bracket, then my range cannot be all real number. For any a1, a2, a3, it will be having some defined, some finite values only. It cannot go up to -infinity to +infinity. So this will be into function and 1, 1 function. So answer for this question will be B. Okay. Now moving to the next question, that is question number 8. This answer was B only. 8. Minimum possible area of the quadrilateral ABCD whose vertices ABCD lies on this parabola, and diagonals AC, BD are perpendicular to each other and pass through 1, 0, and which is actually the focus of this parabola. Okay, now please see what we are given, that this is suppose focus here. So my one of the diagonal is this AC, and other diagonal is perpendicular to this, so maybe like this, BD. Now we are looking for the area of this quadrilateral ABCD. Now to find the area of this quadrilateral, I will use the formula that area is equal to product of lengths of diagonals by 2 into sine theta, angle between them, which is actually 90 here. D1, D2 are the lengths AC and BD by 2 into sine theta. Okay, now sine theta is 90, so we are only looking for the length D1, D2. Now please listen carefully. Suppose this focal chord, because they all are passing through focus, so AC is also focal chord and BD is also focal chord. I think we know this result again. If there is a focal chord making an angle alpha with its axis, then the length of this focal chord AC is equal to 4A upon sine square alpha, 4A into cosecant square alpha. So this AC, if it is making an angle alpha with x-axis, then the AC will be 4A upon sine square alpha. Now BD being perpendicular to AC, so it will be making angle, alpha plus 90. Suppose this is BD. Okay, so the angle here, this would be alpha plus 90. So this length BD will become equal to 4A upon cos alpha, because in place of alpha, we will be putting 90 plus alpha. So AC is 4A upon sine square alpha, BD is 4A upon cos square alpha. So we can put these values here, 1 by 2 into 4 into 4, 16. In fact, the value of A is 1 here. So I need not to write A here. So 16 upon sine square alpha cos square alpha. I think if I multiply by 2 here and 2 here, so 4 sine square alpha cos square alpha will give you sine square 2 alpha. So the minimum value will be when sine 2 alpha takes highest value, that is 1. So it will be always greater than or equal to 32. Greater than or equal to 32. So the minimum value, minimum possible area, I think there is no option matching. So answer for this question is D. Okay. Yeah. Coming to the next question. Here we are given alpha beta are the roots of this quadratic and an is equal to a alpha n minus beta b into beta n. Then we have to find this relation. Now this is based on Newton's formula that whenever you are having this kind of relation, so we always get an plus 2 minus 4an plus 1 plus 3an equal to 0. So there is a direct relation similar to the quadratic. You just have to copy the coefficient, like x square is having 1, so an plus 2 will also have 1. For x it is minus 4, so one term lesser than this n plus 2 will be here multiplied with the same coefficient here, that is 4. Similarly 3an is equal to 0. Now we can find the value of a10 from this by putting n is equal to 8. So it will be 4a9 minus 3a8. Here we are looking for 10, 7 and 8. So I think I need to eliminate this 9 from here. So 4 into, again if I use the same result, this a9 will be equal to 4a8 minus 3a7 minus 3a8. So I will bring this a7 this side. So we get a10 plus 12a7 is equal to 16 into 16 minus 3 is 13a8. If you divide by a8, so answer will be 13. If you divide by a8 here, so answer will be 13. Okay. For this particular question, when I was making this question, I have thought of one more method, that because you can find the roots also. I think one root is 1 here and other root is 3. Then I think you can find a10 to be equal to this a into 1 minus b into 3 power 10. And similarly a7 will be equal to a minus b into 3 power 7 and a8 will be equal to a minus b into 3 power 8. So from this, also by putting these values, you can get the answer, and it is also not difficult. Okay. So moving to the next question, that is the answer was D here. Yeah. So now coming to question number 10, we are given that product of all real values of x satisfying the equation. Here we are given some expressions of log in the power with base 3. So here I will take the log to the base 3 on both sides and taking, let us take log on both sides to the base 3. So the power here, that is log x square, actually log x square base 3 plus log x base 3 whole square minus 10, that will be multiplied outside into log of x base 3 is equal to, that is 1 upon x square, so minus log of x square to the base 3. Okay, I have taken log to this thing, so whatever was in the power will get multiplied. So log x square base 3 plus log x base 3 whole cube minus 10 will be multiplied with log x base 3. On the right hand side, it will be minus log x square base 3. I will take log x base 3 as t, so that I don't have to write this log x thing again and again. So the first thing will be actually 2t, because again the property 2 will come outside, plus t square minus 10 into t is equal to minus 2t. Okay, so one of the factor is already taken common, so we can write t equal to 0, or the remaining thing would be 2t plus t square minus 10 is equal to minus 2. This gives you a quadratic, that is t square plus 2t minus 8 is equal to 0. Okay, from that we get two values. T is equal to, I think, minus 4 and one is 2. Yeah, you can split the middle term as plus 4 minus 2. So t plus 4 will be one factor, t minus 2 will be other factor. So t is equal to minus 4 and 2. Okay, so for log x base 3 we are getting as 0, then it will be 1. For minus 4 it will be 1 upon 3 power 4, and for 2 it will be 3 square, and we have to find the product of all values. Okay, so this becomes, I think, 1 upon 3 power 2, that is 1 upon 9. 1 upon 9 will be the answer of this question, that is B. Okay, so moving to the next question. Distance of the point on this biquadratic function which is nearest to the line y is equal to 12x minus 1 from the line is root lambda, then we have to find the value of 1 upon lambda. Okay, now see, this is 4-degree polynomial, so I don't think we have done such thing in coordinate geometry. This has to be done with the help of maximum minimum. You can think of this will be some graph like this. Okay, and that is a line, maybe something like this. So whenever we are looking for minimum distance, I think it is at that point where tangent become parallel to the given line. The point of minimum, in fact, that is applicable for maximum also. Point of minimum or maximum on this curve from this line will be at that point P where tangent is parallel to this line. So what we are going to do, we will find the derivative of this biquadratic, that is dy upon dx is equal to 4x cube plus 6x plus 2, and that we will like to be equal to 12 because that slope of line is 12. Okay, now here we are getting 4x cube plus 6x minus 10 equal to 0. I think one of the factor is coming out to be 1, x minus 1. The other factors are 4x square will give you 4x cube, but there is no square term, minus 4x square because of this 1. So I have to add 4x here so that 4x square term is cancelled, and then constant term will be 10. You can check. The term of constant is matched, and then the term of x also is matching, minus 4x plus 10x, so 6x. Now this quadratic is having no real root because its d is negative. So only one value of x is there, that is x is equal to 1. Okay, now if there is only one value, then it has to be point where minimum distance will be there because maximum distance will be infinite because this will go up to infinite. So for minimum, x is equal to 1. For x is equal to 1, the value of y will be, if you put 1 here, I think it is 6. So this is the point P 1, 6, and we have to find the perpendicular distance. We have to find the distance of this point from this line. So we will use the distance formula, that 12x minus y minus 1 equal to 0, perpendicular distance formula from 1, 6. So this distance d will be equal to 12 minus 6 minus 1 divided by under root of 144 plus 1, that is 145. Here it is, I think, 5. So it becomes inside under root 5 upon 29. So the value of lambda is 5 upon 29. Value of lambda is 1, 5 upon 29. So the value of 1 upon lambda is equal to, I think, 5.8. So that is the answer for this question, that is D. Moving to the next question, question number 12. Yeah, we are asked the limit x tending to 0, tan sine inverse x minus tan inverse x upon sine x minus tan x. Now this question I can do in two ways. One is LH rule, okay, and otherwise also you can do. So let us try with LH rule only. But before that, let me tell you, if you are thinking that we divide by x in numerator and denominator, this will become 1 minus 1 upon 1 minus 1. That is not correct way because in that case you will get 0 upon 0 form. Okay, so one of the best method could be LH rule only. So if you do the differentiation, x approaches to 0, here it will be 1 upon root 1 minus x square minus 1 upon 1 plus x square divided by cos x minus secant square x. Okay, so that is one time differentiation. If you want, you can do differentiation 2 times also, or maybe we can use the expansion of 1 minus x square power minus half and 1 plus x square. That way also we can do. Please see, limit x approaches to 0. In denominator, if I take secant square common, it will be cos cube minus 1. Cos cube x minus 1. Yeah. And that will be 1 minus x square power minus half minus 1 plus x square power minus 1. Okay. At x is equal to 0, secant square x will be 1. So I think we can ignore that, or we can put the values here. Limit x approaches to 0. And here it is 1. For this also, we will make factors like cos x minus 1. And other factor will be cos square x plus cos x plus 1. Okay. Now the expansion of this would be 1 plus x square by 2 and so on. Minus, for this it will be 1 minus x square minus and so on. Okay. So 1 gets cancelled. In the numerator, limit x approaches to 0. We are getting 3x square by 2. 3x square by 2. Whereas in the denominator, I can put x is equal to 0 in this bracket also, which will give you value as 3. And this is cos x minus 1. This value is 3. So 3 will get cancelled with this thing. And I think this has become now standard result. Limit x approaches to 0. And it is x square upon 1 minus cos x multiplied with, yeah, it is seen. So multiplied with, I think, minus half. Multiplied with minus half. Okay. And this is actually the standard result, 1 minus cos x upon x square, whose limit is half, but it is actually reciprocal of that. So it will be 2, and that is minus half. So answer for this question will be minus 1. Minus 1, that is B. Okay. We could have done this question by converting sine inverse x into tan inverse x upon root 1 minus x square, and then tan inverse A minus tan inverse B formula. That way also we can do this question. Okay, answer will be same. So answer is minus 1, that is B. Yeah. Coming to the next question. Here it's a question of indefinite integration. We are given dx upon x power 4 by 5 into x plus 1 power 6 by 5. You please check the sum of these two powers are 10 by 5, that is 2 in denominator. So basically it is minus 2 if I bring that power in the numerator. So there is one certain type of question that we do in our indefinite integration. For this, what we will do, we will be bringing one x from this bracket outside like this, x plus 1 upon x power 6 by 5. Now what we have done, I have divided by x here. So you will be multiplying one x here, and that I will take outside. So it will become x power 10 by 5 dx. This is actually becoming now dx upon x square whole divided by 1 plus 1 upon x raised to the power 6 upon 5. Now if we take 1 plus 1 upon x as t or t power 5, dx upon x square will convert into dt. I will like to take 1 plus 1 upon x as t power 5. So this gives minus dx upon x square to be equal to 5t power 4 into dt. Now if I put it here, there will be minus sign, minus 5t power 4 dt upon, this is t power 5, so it will be finally t power 6 here, and this will give you t square here. So 1 upon t square, the integration is minus 1 upon t, so it will be 5 upon t plus c, where t is given by this thing. So we can write it as 5 into 1 upon t would be, I think, x upon x plus 1 whole power 1 upon 5 plus c. So that is the answer for this question, 5 into x upon x plus 1 whole power 1 upon 5 plus c, that is c. Okay. Moving to the next question. General solution of this equation. Now please see, this question is of homogeneous type equations. You can try to convert this into what we call as exact differential, where we combine two or more differential terms to make them one, but I think it is not that easy to do. So the best way for this question would be that we write it as homogeneous differential equation. Dy upon dx will be dy upon dx plus x minus y upon x plus 2y is equal to 0. It will become divide by dx, so dy upon dx, and then divide by x plus 2y, so x minus y upon x plus 2y equal to 0. Now for this kind of question, we put y is equal to vx, so we get dy upon dx equal to v plus x into dv upon dx. Okay, so dy upon dx will become v plus x into dv upon dx plus y. If I put vx, then I think x will get cancelled. We will be left with 1 minus v upon 1 plus 2v equal to 0. Now this v we can combine here. Let me do it here. X into dv upon dx plus 1 plus 2v, we can take LCM. So it will be v plus 2v square and plus 1 minus v equal to 0. This 1v gets cancelled and we can write it as 1 plus 2v upon 1 plus 2v square, 1 plus 2v upon 1 plus 2v square into dv plus dx upon x equal to 0. So we need to integrate it to get the answer. I think I can break it into two parts. One is 1 upon, let me write it here only, 1 upon 1 plus 2v square, and other one is 2v upon 1 plus 2v square. For first one, the integration will be in terms of tan inverse. It is 1 upon root 2 tan inverse root 2v. For other one, it would be plus 1 by 2 ln of 1 plus 2v square, because if you take 1 plus 2v square as t, 4v dv will become dt, so 1 by 2 will come there. So 1 by 2 ln 1 plus 2v square plus ln x is equal to some ln c, you can say. Okay, now v is actually y upon x, so my first term will be 1 upon root 2, not seen, let me take it up, yeah. So 1 upon root 2 into tan inverse root 2 into v is actually y upon x plus this 1 by 2, if I write it with ln x also, it will become ln x square. Let me write it like this, 1 upon 2 and x square, take 1 by 2 common, so x will multiply here, x square actually. So 1 by 2 ln of x square plus 2y square is equal to ln c. Okay, I think the answer is this only, but I think they have multiplied by root 2. Let me see. One by root 2 tan inverse, there is no such option. I think root 2 if we multiply, so we will get tan inverse root 2 y upon x. Okay, if we multiply by root 2, actually we have multiplied by 2, so it will be root 2 tan inverse root 2 y upon x plus ln x square plus 2y square equal to 2 log c ln c, which you can write it as k. So answer for this will become D. Yeah, answer will become D. No other option is similar to that. Yeah. So moving to the next question, that is question number 15. This is continuous function at x is equal to 0. So just you need to find the limit. Okay, where e is base of natural log a comma b lies on. For limit x approaches to 0, we can write it as a sine 2x minus 1 upon sine 2x into sine 2x upon x, or rather 2x, and then into 2. So 3, rather actually 2 standard results. The first one will give you ln a, actually log a to the base e, and this will give you 1, and then it is 2. For this to be continuous, this has to be equal to log b base e. Actually this is also base e only, so we are getting a square to be equal to b. So a comma b, a is x coordinate, b is y coordinate, should satisfy which relation? I think y is equal to x square, because we are given b is equal to a square, so a is the correct option, b is not the correct answer. C also doesn't satisfy, because if you put x is equal to a there, y will become 1, that is not the case, and likewise y is equal to a square upon a is also not satisfying it. B is equal to a is also not satisfying, so answer is A for this question. Then question number 16. Here we are given y is equal to fx is a function satisfying f of 10 minus x is equal to fx, and this is also equal to f of x plus 5 for all x. then this definite integration is equal to this thing. We need to find the value of k. Okay, now to do this question, this integral that is given here, we can use the King's rule. King's rule means what? 0 to 10. In place of x, we will put 10 minus x and sine square pi by 2 and 10 minus x here. F of 10 minus x is equal to fx we are given, and this is also sine square 5 pi minus pi x by 2. So because of square, I think this will again be same with positive sign, sine square pi x by 2. In fact, it was not the square, then also it would have been with plus sign only, because 5 pi minus theta for sine will be sine theta. So this is actually becoming same function which was given there. What we can do, we can take 2 common. Actually, this is becoming equal to the same function. Let me write it. Yeah, it is actually becoming the same thing. 0 to 10 f of x and sine square pi x by 2 dx. So even if we use the property of that King's rule, we are getting same integration. So in such case, what we do, we take 2 common, make this limit half, so 0 to 5, then it will be f of x sine square pi x by 2 dx. Now once again we can use the same property, King's rule, so it will be 2 times 0 to 5 f of 5 minus x, and then this time this will become cos square, not sine, cos square pi x by 2. Okay, because if you put x as 5 minus x, then it will be 5 pi by 2 minus pi x by 2. So it will be cos pi x by 2 whole square. Okay, and here please see f of 5 minus x, because we are given this relation also. So let me know, using this relation, can we say that this f of 5 minus x, I can write it as f of 10 minus x, because if we add 5, then fx is equal to f of x plus 5. Same rule will apply here also, and f of 10 minus x is also equal to f of x. So this f of 5 minus x becomes equal to fx. So this I is actually becoming equal to 2 times 0 to 5 fx into cos square pi x upon 2 dx. Now these two things we can add, and if we add, fx will be common, and this sine square plus cos square will become 1. So I plus I, that is 2i, will be equal to 2 outside 0 to 5. Okay, and then just fx dx. So we are getting I to be equal to, 0 to 5 fx dx. If we apply King's rule once again, it will be same thing, because f of 5 minus x, I have proved here, is equal to f of x. So if I use King's rule here, it will be same thing. So it will be better we use 2 times 0 to 5 by 2 f of x dx. And I think this is what they are asking. It will be k times 0 to 5 by 2, k times 0 to 5 by 2 fx dx. Okay, so the value of k here should be equal to 2. The value of k here should be equal to 2, that is A. Okay. Moving to the next question. Let x denote the total number of 1, 1 functions from set A with 3 elements. Okay, so A is having 3 elements, maybe 1, 2, 3, and 2 of set B, that is having 5 elements, let us say A, B, C, D, E. Okay, so, and why denote the number of onto functions from the set B to set A. Okay, so let us do it one by one. So first of all, number of 1, 1 functions from A to B. So for 1, 1 function, I need exactly 3 images, and each images will be connected to different elements 1, 2, and 3. So for that, I need to choose 3 elements out of these 5 in 5C3 ways, and these 3 elements, let us say A, B, C, will be connected with 1, 2, 3 in 3 factorial ways. It becomes 10 into 6, that is 60. That is the value of x. Okay, now to get the value of y, we need to have 5 elements here, A, B, C, D, E, and here it is 1, 2, 3. Okay, so from B to A, we want onto function. I think it can be done in 2 ways. One is inclusion, exclusion, that is better method. First, we will be counting all functions. All functions means in how many ways we can create a function. So A will be having 3 choices. And if onto is not a condition, we will also have 3 options. So this way it will be 3 power 5 if all functions are to be considered. But out of this, there will be many functions which are not on 2, and they will be when suppose 1 is not chosen. Okay, maybe 2 is not chosen or 3 is not chosen. So which is not chosen? So 3c one ways, and then all the 5 elements are connected to the remaining 2. So into 2 power 5. Okay, but in this case, there is a possibility when you are excluding 1 and you are adding all 5 elements to 2, 3 in 2 power 5 ways. One of the possibilities, in fact, in 2 of the possibilities, all elements will go to 2 or all elements will go to 3. So in this calculation, we have actually counted those cases also in which all elements are going to 3 or 2. And this counting actually gives you double subtraction here, because when 1 is excluded, then in one of the case you are getting all A, B, C, D, E going to 2. When you will exclude 3, then also in one of the possibilities all elements A, B, C, D, E will go to 2. So all elements going to 2 is actually double subtracted here. So we will be adding such cases once, and that is when 3C2, which 2 elements you are not going to choose, and then all elements are going to be connected to the remaining 1 element. So 3 power 5 minus 3C1 into 2 power 5 plus 3C2 into 1 power 5. That is one very standard process of getting the onto functions. So you will get here 3 power 5 is I think 243 minus I think 96 plus 3. So 246 minus 96 is I think 150. So that is why now we are given x as 60 and y as 150. They are equal. From there, if you do the calculation, you get 5x is equal to 2y. 5x is equal to 2y. Okay, so answer here is D. The other method for finding the onto function is actually group formation. You make groups of which elements will be connected to which element here. Like 3 elements here can be connected to, let's say, 1, and then 1D connected to 2 and E connected to 3. So this kind of grouping can be done for the elements of B, and then we can connect them. There you have to make some cases. That is also standard way. Okay, so that way also you can check. Answer will be same. Question number 18. Here we are given an ellipse whose eccentricity is 1/2 has focus and corresponding vertex as origin, and x plus y equal to 2. Okay, so this is the ellipse, let us say, and that's the directrix. X plus y is equal to 2. And please consider this thing that this is not the standard ellipse where major axis is along x-axis, because x plus y equal to 2 will be a line that is making some angle 135 with positive x-axis. So this diagram will actually be some tilted one. Okay, and this is the center, let us say. This is the focus. This is given to be at 0, 0. Okay, and then there will be another focus S dash, and then there will be another directrix on that side. And I think we are looking for that other directrix only. Now please see how we can do this question. First of all, this perpendicular distance of S from this line is 2 upon root 2. That is root 2 only. If you put 0, 0 here, so we get 2 upon root 2. So that's the perpendicular distance of focus from the directrix, which is equal to A upon E minus AE. If you compare with the standard ellipse, then it is at x is equal to A by E, and focus is at AE comma 0. So distance will be A upon E minus AE. We are given eccentricity to be half. So this will be 2A minus A by 2. So this is 3A by 2. So from that we get A to be equal to 2 root 2 upon 3. 2 root 2 upon 3. Okay. Now we are looking for the other directrix. If you check the distance of this focus directly to this directrix, I think it will be 2AE till this point, or maybe let's do one thing. This is AE here, this C to this S, and this C to this is actually A upon E. Okay, so the other distance, the distance of this focus to the other directrix will be A by E plus AE. A by E plus AE, yeah. That will be equal to, I think, 2A plus A by 2. So that is 5A by 2. And A we got 2 root 2 by 3. So it will be equal to 5 root 2 upon 3. Okay. So my this directrix should be at distance 5 root 2 upon 3 from this focus, and such that focus lies between these two parallel lines. Okay, now this will be parallel to this line only. We can consider that to be x plus y plus lambda equal to 0, whose perpendicular distance from focus, that is lambda upon root 2 mod, will be equal to this 5 root 2 upon 3. So from that we get lambda to be equal to root 2 get multiplied, so 10 upon 3 or plus minus 10 upon 3. Okay, here if you see, the equation is x plus y minus 2 equal to 0. Okay, now if you take minus here also, because I have taken lambda on that side, if you take minus sign here also, then this focus cannot lie between these two lines. For focus 0 0 2 lies between these two lines to be, then lambda has to be with plus sign. So that means lambda will be 10 upon 3. So answer for this question will be C. Okay, I hope you are getting what I'm trying to say. That see, you can do in two ways. One more way, that if you're taking this line with minus sign, okay, with minus sign, then if you check the distance between this line and this line, which has to be equal to 2a upon e, I think it will not match. It will only match if you take lambda to be equal to 10 upon 3. So answer for this will be C here. Okay, moving to the next question, that is 19. This is a question on definite integration and differentiation by Leibniz rule. In fact, yeah, special case where x is also inside. If you differentiate it with respect to x, okay, so the first differentiation would be when you do the differentiation of the upper limit, that is 1, and you put t as equal to x, which will make this entire thing to be equal to 0, plus 0 to x. You do the partial differentiation here with respect to x. So differentiation of x minus t with respect to x will be just 1 into f dash t dt plus 2x. Okay. Also from this relation you can check your f0, because if you put x is equal to 0, your definite integration will give you value equal to 0, and x square will also give you 0, so that will be 0 here. Now f dash is equal to this thing. If you integrate it, I think it will be f t only. So it will become fx upper limit minus f0, which is actually 0 here, plus 2x. Okay, so this is becoming dy upon dx equal to y plus 2x. One linear differential equation. Dy upon dx is equal to y plus 2x. So we will be writing it as, I have taken fx as y here. Okay, so dy upon dx minus y is equal to 2x. So here you can check integrating factor is equal to e power minus x, because the coefficient of y is minus 1. So integrating factor is minus x, and the solution would be y into e power minus x equal to 2x into e power minus x dx. This integration is done with the help of integration by parts. First function, second function. So we will be getting first function as it is. Integration of second function will be with minus sign here, then minus, and then differentiation of this first function. So 2, integration of this will be one more minus sign, so minus minus plus here. Okay, and then it becomes minus 2x e power minus x plus, not actually plus, minus sign 2 e power minus x plus some constant c, and value at 0 has to be 0. So, or let me first write like this, fy is equal to minus 2x minus 2 plus c into e power x. Okay, at x is equal to 0, let me do this calculation here. At x is equal to 0, y is also equal to 0, because f0 was 0. So 0 equal to minus 2 plus c. So the value of c is equal to 2. Now we have to find the value of this function at 1. Yeah, f1 we have to find. So the f1 would be f1 or y1, both are same thing. So it will be minus 2 into e, not e, minus 2. I will be putting here. So minus 2 plus c, the value of c is 2 into e. So that is 2e minus 4. So answer of this question is 2e minus 4, that is C. Okay. So I think not very difficult question, but yeah, this differentiation, if you are not aware, then it can be a bit difficult. Coming to 20th question, here we are given that A and B are two events such that f of b by a is equal to 2 by 5, probability of a upon b is 1 upon 7, and we are also given probability of a intersection b to be 1 upon 9. Now the formula for this is probability a intersection b upon probability of a, which is given to us as 2 upon 5. And we are also given probability of a intersection b, that is 1 upon 9. So from this we will be able to find probability of a, which is coming out to be, I think 5 will get multiplied here, so 5 upon 18. 5 upon 18, yeah. Similarly, for this one, the probability of a upon b, which is 1 upon 7, we can write probability of a intersection b, that is 1 upon 9 here, divided by probability of b, that we will find from this relation. So we will be getting probability of b to be equal to 7 upon 9. 7 upon 9. Now after that, I will like to make one Venn diagram to see how these probabilities are looking like. This is A, this is B, and the intersection portion having probability 1 upon 9. Probability of A is 5 by 18, so here it will be 3 upon 18. We can write 1 upon 6 also. 5 upon 18 minus 1 upon 9, 5 minus 2, 3 upon 18, yeah. And for B, total probability for B is 7 by 9, so here we will be having 6 upon 9. Okay, 6 plus 1, 7 upon 9, 7 into 2, 14 plus 3, 17 upon 18. So remaining property outside is 1 upon 18. So that is how everything is mentioned in this Venn diagram. Okay, now we are looking for probability of A upon A dash upon B dash, which means we are looking for probability of A dash intersection B dash upon probability of B dash. Okay, now first let us see what is probability of B dash. B dash means which is not there in B. That means 3 by 18 and 1 by 18. So it will be 4 by 18 here. That is the probability of B dash. Now what is A dash intersection B dash? I think neither A nor B. It is just outside that circles of A and B. So 1 upon 18 here. So the answer for this would be 1 upon 4. That is B. Okay. I think this completes the SCQs. Now coming to integer answer questions. Here we are given mean and variance of 5 observations x1, x2, x3, x4, x5 to be 24 by 5 and 194 upon 25 respectively. Okay. If the variance of this, I think all data x1, x2, x3, x4, x5, they are multiplied by 3 by 2, 3 by 2, 3 by 2, 3 by 2. And one extra data is also given as 9. Now variance of this is sigma, then we have to find sigma upon 5. Now to do this question, what I'll suggest here, for this data set, if I keep 3 by 2 outside, okay, here we will be having x1, x2, x3, x4, x5, and this one would be 6. Okay, if you take 3 by 2 common from 9, I think it will be 6. Yeah. Now we already know the variance mean of all this of this 5 data. So that means we are just adding one extra data as 6. Now, if we find the variance of this thing, then we just have to multiply by 3 by 2 square. That's a property. If every data is multiplied by, let's say, k, then variance becomes k square times the old variance. So this is how we can do it. Okay. Now we are given mean of this thing as 24 by 5. Just 1 minute. Okay, fine. So old mean was I think 24 by 5. So I can write the summation of sigma of xi to be equal to 5 into this, or 24. So for new data, that will be actually sigma xi plus 6 also will be equal to 30. And if we look for the new mean, because now we are having 6 data, so it will be equal to 5. Okay. Now to find the sigma xi squares, because we need sigma xi squares also for variance, I will use the old variance. The old variance was 194 upon 25, and that is equal to sigma xi square upon 5 minus square of mean, that is 24 by 5. Okay, so we can multiply by 25, we will get 194 here equal to 5 times sigma xi square minus 24 square, which is I think 576. Okay, so doing the calculation here will give us sigma xi square is equal to 576 will go that side, so 200 770 upon 5, that is 154. Okay, so the sum of squares of old 5 data is 154, but the thing that we are looking for is variance of this data, in which 6 is also there. Okay, now let us write sigma xi square plus 6 square, the square of extra data, so that will be equal to 154 plus 36. I think it will become 190. 36 plus 54 is 90, so 190. So the new variance which we are looking for is, so the variance would be summation of squares, that is 190, divided by 6 because number of data is 6, minus mean of the data, that is 5 square. So this will become 190 upon 6. I think we can take 6 as LCM, so it will be 150 here. So it has become 40 upon 6, so 20 upon 3. So new variance is 20 upon 3, but wait, this is when we have not multiplied 3 by 2, or rather we have taken 3 by 2 common. If 3 by 2 is common, so the required variance would be 9 by 4 times square of this times that variance we have found, that is 20 by 3. So 3 cancel 3 times, 4 cancel 5 times, so it will be 15. Okay, so that is the new variance 15, and we are looking for variance divided by 5. So answer of this would be 3. Answer would be 3 for this question. Okay. We are given area of the region given by A equal to bracket x comma y, such that x square less than or equal to y less than or equal to maximum x plus 2 comma 4 minus 3x is k. Then we have to find 2k upon 50. Okay, please see here we have to draw the region first. So I think here we are given first region as y greater than or equal to x square, which is the upward parabola, y greater than or equal to x square. Okay, and then other one is maximum of x plus 2 comma 4 minus 3x. The line x plus 2 is like having y intercept to be 2, something like this. This is y is equal to x plus 2 having y intercept to be 2, x intercept to minus 2. The other line is having y intercept as 4, okay, and slope is minus 3, so something like this. So it will be intersecting the parabola somewhere here. Okay, now maximum of these two lines, this line is y is equal to 4 minus 3x. So out of these two lines, the maximum would be from this point to this point, 4 minus 3x will be maximum, and after that this x plus 2 will be maximum. Okay, and we are actually looking for the area of this region. Okay, now let us do some solving. If I put y is equal to x plus 2 in this curve, y is equal to x square, I think we get this point to be 2 comma 4. Okay, and this point 4 minus 3x, if solved with x square, this will be minus 4 comma 16. If you put x is equal to minus 4, this is giving 16, and that is also giving 16. So minus 4 comma 16. Whereas this is the point of intersection of these two lines, x plus 2 and 4 minus 3x, whose x coordinate is half and y coordinate is 5 by 2. Yeah, if you put half, it gives you 5 by 2. If you put half, that also gives you 5 by 2. So we have to find the area of this region. Now there can be two ways. One is by integration. I think that is much obvious thing, that we do the integration from minus 4 to half, where the above function would be 4 minus 3x and the lower function would be this x square. Okay, and then from 1 by 2 to that 2, 1 by 2 to 2, above function would be x plus 2 minus x square dx. So just do the integration, you get the answer. Here what we can do, we can split this integration as minus 4 to 1 by 2, 4 minus 3x plus 1 by 2 to 2 x plus 2 dx, and this minus x square thing, why to split it into two parts? Because we can write directly also minus 4 to 2. I think it will save our calculation. Okay, because even if you do in two different parts, then also you'll get same answer. Okay, now for the first thing, let me use this space. Yeah, so that is integration of 4 will be 4x, and you put the upper limit minus lower limit, that is 1 by 4 plus 1 by 2 plus 4. I think it will become 4.5. Integration of 4 is 4x, and then I put upper limit half, lower limit minus 4, so 4.5. Then minus 3 by 2 x square. For x square, it will be 1 by 4 minus 16. 1 by 4 minus 16. That is for the first part, plus. For second part, it will be 1 by 2 into x square, and here it would be 4 minus 1 by 4. Then plus 2 into x, so it will be 2 into 3 by 2. And for the last one, 1 by 3 into x cube, so it will be cube is 8 plus 64. Okay, so we have to do this calculation. There is no other option. 4 into 4.5 is 18, at least when you're doing the integration. Okay, and here it will be how much? 16 minus 1 by 4 is 63 by 4. 63 by 4, so plus 63 into 3 is, I think 63 into 3 is 189. Yeah, 189 upon 8. 64 minus 1 is 63. 63 into 3 is 189. Yeah, that's correct. And then this is 4 minus 1 by 4 is 15 by 4. So 15 by 8. Plus 3 only. And plus 8 plus 64 is 72. 72 by 3 is 24. So I think I have to subtract minus 24 here. Can I write it here? I think we can. Minus 24. Okay, so this is what we have to solve. So it is 18 plus 15 plus 189 would be 204. 204 upon 8. 204 upon 8 is how much? 1 minute. 204, yeah. 204 upon 8 is coming out to be in fraction. Yeah. Or I have done something wrong here. Four times, this is right, correct. 3 by 2 is right. 1 by 2, 2. With 2, it is 3 by 2 only. With 1 by 2, 4 minus 1 by 4 is right. 1 by 8 term will come here. 204 upon 8 is 25 upon 5 plus minus 21. Yeah, minus 21. So minus 3. So it will be 25.5 minus 3 is how much? 22.5. 22.5. Yeah, maybe that is the answer. So K is actually 22.5. Okay, and this 2K upon 15, if we solve, 2K upon 15 we have to find will be 45 upon 15, that is 3. Yeah, that is right. I think there is no confusion. Answer is 3 only. Yeah, correct. Now I have done actually this question different way. I normally don't do this method. I have a shortcut. Please see what is that shortcut. We have a method that is known as To-Do's theorem. To-Do's theorem, where we can find this area directly. The area bounded between A, B and this parabola. This we can find directly. Please see how this can be done. I'll tell you the method here. I'll use this diagram if needed. So for any parabola like this, if there is a line that is intersecting it at 2 points A, B, then this area can be found directly. You just take the projection of AB over tangent at vertex of this line AB. Take the projection of this line AB over length at tangent at vertex, and let's say this distance is D here. then this area is directly equal to d cube upon 6L. L is latest rectum. L is latest rectum. And in this case, please see, if I use this formula, you can see the projection on this tangent at vertex would be minus 4 to 2, so 6. So 6 cube upon 6 into latest rectum, because this is y square, y is equal to x square, so it is just 1. So your area of this thing will be 36. This area here would, not this one, yeah, the area, this one would be 36. From this, if I can subtract the area of this triangle, which we can do because this triangle is having 3 vertices and we know all the 3 vertices, 2, 4, 1 by 2, 5 by 2 and minus 4, 16. So subtracting the area of this triangle from 36 will also give us the answer. This way we can do this question. Okay. So moving to the next question, that is 23. Here we are given A, B are 2 points, and if the point P lies on y-axis such that PA minus PB is maximum, then okay. Now please see, this is a question based on certain properties of reflection. So here we are given A point and B point. A is 3, 2 and B is 2, 5. In fact, in this case, it is not reflection. It is just simple property of a triangle. Now, suppose you take P somewhere here because its x coordinate is 0. Okay. And what we are looking for? We are looking for PA minus PB. Now, please see the difference PA minus PB will be greater than or equal to AB. Will be greater than or equal to AB. Triangle inequation. It can be equal to AB only if my P is actually on the line joining AB. If I choose P to be here, then only this PA minus PB mod will be equal to AB, and that will be the maximum value of this difference. Okay, so this will be applicable if we take P on the line joining AB and also lying on the y-axis. So that is all we need to do. Now there can be 2 methods. Again, see, this line is having slope to be equal to 5 minus 2, 3, I think minus 3. So the equation of this line will become y is equal to minus 3, and this point 3, 2, if you put it here, I think plus 11, yeah, plus 11. So that's the equation of this line. This point is also satisfying. We can check, yeah. Now point P has to have x equal to 0. So the y coordinate will be 11. So P point is 0, 11. So the value of K is 11. So answer for this will be 11 plus 7 upon 2, I think 9. Okay, I was talking about some other method. Please listen carefully. From B to A, if we are going, because it's a straight line, the x coordinate is increasing by 3. I think I have written these points differently. Maybe this point will come here. Yeah. 3, 2 will come here and 2, 5 will come here. I think earlier calculation will not change if I write otherwise also. But here what I'm going to tell you, that from B to A, if you go, your x coordinate is reducing by 1 and y coordinate is increasing by 3. Now we want to go to B point where we want x coordinate to be reduced by 2, and because it's a line, so y coordinate should be increased by, what was the increase here? 3. So it should increase by 2 times of the 3, that is 6. So 6 plus 5 is 11. So that is how also you can conclude the y coordinate of P, that is coming out to be same as the 11. So answer here is 9. Okay, now coming to the next question. Question number 24, I think very simple question based on the properties of binomial theorem, binomial coefficients actually. Sigma r into NCR plus 3 times sigma NCR. Here r is from 0 to 6. Here also 0 to 6. So that's a standard result. Sigma r into NCR is n into 2 power n minus 1, and here 2 power n. The value of n is 6 here. So it will be 6 into 2 power 5 plus 3 into 2 power 6. We can take 3 into 2 power 6 common. In fact, this is 3 into 2 power 6 only, and this is also 3 into 2 power 6 only. So 1 plus 1. It becomes 3 into 2 power 7. And what we are looking for? A upon 64. So A upon 64. This is actually A. So divided by 64 means it will be, I think, 6. 64 is 2 power 6. So the answer for this will be 6. Yeah. Now the last question of this paper. Here we are given fx is equal to x cube plus 4x minus 3 and gx is the inverse of fx. Then we have to find the value of 7 into g dash 2, where g dash is actually derivative of g function. Okay, so in this case we will use the property that f of gx is equal to x. So if we differentiate it, we will get f dash gx into g dash x is equal to 1, and we are looking for g dash x. In fact, g dash 2 we are looking for, so it will be g dash 2 is equal to f dash upon g of 2. Okay, now look at this function where f of 1 is actually equal to 2. If f is 1, f of 1 is equal to 2, then g of 2, because g is inverse of f, has to be equal to 1. So from this g2, if I put as 1, this will be 1 upon f dash 1. Now f dash 1 can be found from that formula of fx, that is 1 upon 3 into x square, put x is equal to 1, so 3 plus 4, that is 1 upon 7. So g dash 2 is coming out to be 1 upon 7, and we are looking for 7 times g dash 2. So answer of this would be 1. Okay, so I hope you will like all these solutions. This completes my solution of this paper. So thank you so much, all of you. I'll come back again with one more paper, some other papers once again. Till then, bye.